Hello everyone, welcome back. This is full-free Python crash course, which we're going to cover all sides of Python and make you full Python developer by end of this course. So subscribe to catch next videos and let's jump into the video. Python is most popular programming language in the world, and it was created in 1991 and very simple to learn, and it have lots of usage in programming world. And why we should learn it? Well, Python is used in web development for rapid development, especially because it's very simple to learn and it's going to save lots of time for us. Another usage of Python is in game development. Then you can write and code automations in different scenarios using Python very simply. And another usage of Python is in finance, which you can create your automated trading bots such as expert advisors or some analysis AI to help you do your work and trading. Another thing which Python is very popular in that field is data science and machine learning, which of course you can use other languages like C or other ones, but Python, because of its simplicity and pure lines of code, is really the best choice for this. And the last one, which is very popular now in the world, is AI. And with Python, you can create your own AI or implement other AIs into your own and release your version of artificial intelligence. But let's talk about who is this course for. Well, if you're absolute beginner to programming and you don't know anything about programming, Python is one of the best choice that you can have to enter this field. Because of its simplicity in explanation and its very simple syntax, you can start learning code and you can code your first applications using Python very good and easy. If you're a student which you need to do some homework or research and you need to code something around it, Python probably is your best choice. Because again, it's simple to learn and you can do lots of work with this programming language. The next group of people which this course is very useful for them are web developer or app developers that are currently working. Again, because Python is very quick to write and it has very simple syntax, it's very good to use on rapid development and you can create your web applications, websites or applications so much quicker with Python than other languages. And other group of people which this course is very useful for them are data science and AI interested people, because Python is now most popular language in the world as well as most popular language in this field of data science and AI implementation. So if you want to start your journey in AI or anything related to programming, Python is one of the best programming language and probably the best programming language that you can start with. And in this course, we're going to have this roadmap, which at first we're going to start with the basics of variables, data types, functions, and how to start coding and implementing these items in our codes. Then we're going to cover loops and conditionals like for, if, while, elif, and other things that you need to know to start coding beautiful apps and scripts. Then we're going to cover object-oriented programming, subjects like classes, objects, constructors, or other thing which is very useful in complex application and helps us know and manage our program and code very much easy. Then we're going to cover file handling in Python, which how we can interact with other files like text file, HTML file, or anything that you might have in your mind. And we're going to do actions like reading the content inside of that file, writing new lines into it, or change something in that file and content. After that, we're going to cover error management in Python using try, except, finally. And after this part, we're going to have our advanced Python series, which includes using some popular libraries like NumPy, Turtles, or other things. And we're going to have some GUI projects implementing 0 to 100 after learned all about Python. And at the end, we're going to have some examples of how we can use Python in the real world. In this crash course, we're going to start from absolute zero. I'll show you how to install Python and the code editor and set everything up and write our first Python program in that. So first thing that we need to do is having installed Python. And for that, what you need to do is simply search for Python in Google. And then you can see here you got this python.org, and when you click on that, here you can see this download, and if you press, you can see the latest version of Python for your operating system. I'm using Windows, and this is what I'm going to download. If you're using Linux, macOS, or other operating systems, you can download other things from here. But for me, it's this Python right here, and we wait to this download. After your download finished, you simply open this installer, and here when you want to install, make sure to check this box of add Python to the path. And then after you done this, you simply click on this install now and you wait the installation to be complete. Now after you seeing this page, it means we have installed Python. But for checking that, what we need to do is having our CMD open. And then here, we simply type this Python. And because I have this misspelled, if I correct that, you can see this is the thing that we got if we have our Python installed correctly. And another thing that I want you to do is open your path variables if you are on Windows. And if you have this path in your search box, you can see this is the thing that you got. And here in the path, if you double click on this, you can see this is the path variable for Python, and you should see the version that you have downloaded Python to use. Because I have installed Python 3.10 before, it's going to appear here too. But you need only one and the latest version to go. And after doing this, another thing that we're going to do is installing code editor. And for that, I'm going to use this VS Code, which is very lightweight and awesome to use. And after going to this Visual Studio website, which is this code.visualstudio.com, you can see here you got this download button. And if you click on this, it's going to start download for you. And then we wait this to be complete too. And after it's finished, we simply click on that, press this run, and then here we simply install our VS Code. And pay attention here. You need to make sure that this item which is at the path is have checked. Simply press next and then install. And after you install that item too, you should have both of the necessary things that we need. And then we close these two windows and open our code editor. Which because I have installed themes, this is going to be shown a little different in your system and PC. And then we need to add repository and folder to our main explorer. And for that, you simply have to create folder. So I'm going to create folder here. We name that Python simply. And then you can both click here and select that from your desktop, or you can drag and drop that to this section right here. And then after you done this, you can create Python files here in your VS Code. And this is the button that we're going to create one. For example, for the start, we're going to create a file with the name of this hello.py, which is extension to Python. And then after you got this, you can code your first program, which is this print. And then inside of that, we're going to have the simple hello world right here. And after you got this item, if you press Ctrl and J, you can see your terminal is going to open here at the bottom of your code editor. And then here, if you use this ls command, it's going to show you the list of files in your directory. And for running this Python file that we just created, what you need to do is simply type this Python and then followed by that the name of your file, which in our case is going to be this hello.py. And when you press enter, you can see here it's going to run and print hello world for us. But there is another way which we can use to make our work much easier, and we can deal with our Python files and see our results much better. And that's by using extensions. Here, if you click on this extensions button that you can see right here, if you search here for Python, you can see here we got this Python extension which I want you to install. As well as this, it's going to be very good to install this Python debugger right here, as well as this Pylance, which is another cool extension for you. And the other thing that I want you install is this code runner right here. And after you installed all of these 4 items, if you come to here in your file, you can see here you got this play button. And now if we in this file and press this, it's going to run our file for us. And it doesn't matter what you put right here. You can see if you press this, it's going to run the file for you. But there's another way that you can run your file too. And if you want to do, go to your folder which your file is inside of that, and here open your CMD or terminal, which I'm going to open my terminal right here. And then here again, you can run this python hello.py, and again this is going to run the file for you. And if you want to make your work easier, make sure to, in this file section, come and check this autosave so it automatically saves all of the changes that you made in your file. But another cool thing that you might need using Python is going to be this pipe. And if you simply have that pipe run on your terminal, you might see something like this, or if you want to check the version, you simply have this pipe, double dash and version, and this is going to show the pipe version for you. And if this is not installed on your PC, go back to your Python installer that we just downloaded, and here you can see this modify button. And here make sure you hit this pipe option right here. And then if you click the next and install, it's going to install the pipe for you too. And that's it for this part. You have successfully installed Python, set up your code editor, and run your first program. In this part, we're going to talk about variables, data types, and how we can name them in the best way and use them later in our code. As you know from the last part, we got our Python folder attached to our VS Code directory right here. And here I'm going to create our first file, which is going to be our main.py. Then here we can start coding our first Python program. The first topic that I want to talk about is our variables. Variables are something like a bucket that we can put anything and any value that we want inside of that, and when we want to use that again, we can use that as many times as we want in different places. And what we need to do is only name the bucket that has our target value inside of that. For example, let's say we want to have this random number in some variables and use this several times in different parts of our codes. For declaring variables, what we need to do is simply having the name of our variable and then equal that with the value that we want, which I'm going to cover the rules of naming in a minute. Then whenever we want to use that, for example, we have this function and method of printing, which if we want to print something in our console, for example, we want to print this number in our console, when we run our program, you can see it's going to show that in terminal for us. You know, you can use this button of run to run your code if you had .run extension in VS Code as well as Python extension, or you can use manually running in your terminal too. But think of this way that we have several prints in separate parts of our program. And when we want to change only one digit in this number, we need to change all of these items manually one by one. And this time, if we print, all of them are going to change and show us new values. Which if you want to keep track of new printing and new coming to the output, make sure to turn on this auto scrolling so it always be at the bottom of your output. And now if we again print these, you can see all 4 of these are new numbers. If we want to change another digit, for example, if we change this in only our first one, you can see here, this time only our first one has changed and all of the others are the same. But if we use variables, you can see this is the number that we have and this is simply the same bucket that I've told you. And when we want to use this number, instead of having the number itself, we're going to grab the name of our variable, which in this case is the word name, and then we can print that just like this. And this time if we run again, you can see we got all 4 of those numbers printing. But this time, because we have used variables, if we change the digit of this number up here in our variable, If we run again, you can see all of those 4 items have been changed. As I told you, you can name your variable anything that you want. For example here, let's make the name of our variable to be a. And let's get rid of these other prints, so we only need one print right here. And then here, if we again change this and run again, you can see the new value is coming up. But what are the rules of naming that we should follow? In the naming part, we have 4 different rules that we should make sure to follow them. The first one is our variable's name must start with some letters that we want or some underscore. And we can't start with anything which is not a letter or underscore. For example, we cannot start our variable's name by this. The second one is we cannot start our variable's name with numbers. We can have some numbers inside of our variables or at the end of that, but our variable's name should not start with the number. And the other thing that we have is not having space in between of parts of our variable's name. For example, let's say here we want to name this first number. If we have this just like this, you can see we got some space right here, and this is not good and we cannot use this. We can have this underscore here, or we can use this capital N here for separating these 2 parts from each other, but we can't have this type of space between of our items. And the last rule is we cannot use some pre-reserved words. The words like if, for, class or other things which you're gonna learn through the course, which these words are reserved in Python for doing some other things. For example, you can see we got this print word for printing our item into the console, and we cannot use the same name as a function. So we name this print word pre-reserved word for the Python. So let's name our variable the same number that we got earlier, and the name that we want to use in this print is going to be again the same number variable that we got right here. But pay attention, you can have several variables in your code through your applications and apps. For example, let's say here we're going to have some other variable which this holds some name. For example, let's say it holds the name of Jack. And when we want to print that, of course, we're going to use our print function, and then inside of this, we're going to have this name. And this time, if we run, you can see we got the same number right here, and then our name, which was Jack right here. But you can see here, we got some other things than our name right here, which are these 2 quotation marks. And if I remove them and if we run again, you can see we got some error coming here, which is this: the name Jack is not defined. And that's because we have several data types in Python, which are going to be different things that we can put in our variables. So basically the data types are different things that we can put inside of our buckets that we can reuse them again later in our program. The first type of our data types are the numbers. And as you can see right here, this is some number data type, which we call this integer 2. So we got this number or integers right here. The next type that we're going to talk about is our floats. And what floats are, those are basically the same numbers that we can have, but with some decimals after the last number. So here, for example, we got this .43 as decimal, and this is going to be in float part and not integer. So the whole numbers are going to be integer numbers like 5, 4, 3, 2, all of them. And the other numbers which has decimals are going to be in this category of float numbers. The next thing that we have are strings. And strings are basically words or any characters that we need to be inside of our variables. For example, as you saw earlier, we got this Jack. If we put this like this, we got some error going on. And the way that we define a string, by having these between of double quotations or simply single quotations around of our word. And this is as same as we got, for example, this other string 1, and here this time we got this with double quotations and not single one. The next one that we're going to talk is our Boolean variables and data types, which these are going to hold us one of 2 states of true or false. You can have this as true or you can have this as false. But pay attention, in programming, 0 means false and 1 means true. So you can have this both way of this false and true words, or you can have this simply 0 for false and 1 for true. And the other thing that I want you to know is our comments in programming, which when we got some line of codes that we want them to be note for ourselves and we don't want those items to be run in our program, we're going to use comments. And comments are basically some part of the codes that our compiler don't want to run that. And the way that we're going to do that is having this sharp at the beginning of our comment. And then we can write anything that we want. And this line that we got commented, you can see it has highlighted in different way and is not going to run through our program. But pay attention, you can have your codes to be in comments too. For example, let's say here we got print the str instead of that number, and let's make these two items. If we run once and clear our console and stick to the bottom of our output, you can see we got our jack word printing twice. But if we comment one of these just like this, which in VS Code it has the shortcut of Control/, it makes the code and the line that you're inside of that comment so the compiler can't run that. And now because we got one of them in the comment and other one as regular code right here, if we run again, you can see this time we only got one jack and one printing in our output. But you can have comments in the same line that you have your other code. For example, here, if I put this sharp right here, anything I put after of this is going to be comment. But the things and codes before of this character and this sharp is going to be run normally. So if you want to have some explanation or some description about the line that you're writing, this is the way and this is where you're going to type that. For example, let's say we want to name this the integer, and then we want this item to be this float. We can have this one to be string. You can have some with no comments, and at the last you can have the other one which says this is boolean, and you can have some extra explanation or note for yourself. For example, let's say we want to have 0 is false and 1 is true. After these items, we got some other data types which we're going to cover in the next parts, which are a little bit complex data types. But for now, this is what we got. And make sure your variables name are different than each other. For example, let's say here we only have this a, which has this value of 2 inside of it. If we want to print that a here in our print function and method, you can see right here, if we run, you can see we got our value of true printing. But if we have another a right here, and this time we put number 5 inside of our variable, if we run again, you can see this time we got this 5 and we don't have any access to this 2 data that we put right here. And when we use this a again and assign this 5 to this name and this variable, this 5 is going to be inside of a instead of this 2. But another thing that you can have is, let's say we got this 3 variables of a is 1, b is 2, and then we got this c, which is this 3. We can declare our variables like this, and then we can print them separately just like this as we did earlier with our other variables. But the other thing that we can do is, instead of having those type, we got this a and separate that with this comma, then we're going to have this b, and then we separate that with c, and then we equal that, and here we need to pass some numbers. If we have this 1, for example, if we run this, you can see we got some error, which we got less numbers for our variables. But if we want to have 3 variables right here, we should have 3 datas right here too. For example, here let's say we got this 2 for b and then this 3 for c. Pay attention, this is sensitive to the order, so this a has value of 1, b has value of 2, and this c has value of 3. And now this time if we run this, you can see again we got our desired result right here. And if you want to know what type of variable that you're dealing with, you can use the simply type method that we have in our Python. And for that, what you need to do is simply print, and inside of these parentheses of print, which you put anything that you want to print right here, you put this function of type again, and inside of this type, which has its own parentheses right here, you pass the name of the variable that you want to check. For example, here, if I put this a right here and run my code, you can see we got this class int. And I'm going to cover and we're going to see what this class means, but for now this is the part that you need, which this is integer. And if we have this some string, for example, let's say we got this test word, if we run again, you can see this time we got this str, which stands for string. Of course, we can have our booleans. Let's say this is our true value. If we run again, you can see we got this bool, which, as I told you, means boolean. And of course, you can have some other types of boolean with 0 and 1. But if we put this 0, you can see we got this int right here. Or the other example of this, let's say we got this 25 number, but we passed that in this quotation marks. If we run this, you can see we got this string coming up, but this is not a string and this is number. But our code doesn't understand that because we passed that inside of these quotation marks. It's going to make the type of this variable to string. Think of this, that bucket has some card with that, which holds some data about that bucket and variable that we got. When we do simply 25 just like this, it's going to name the type of the variable integer. But if we have this as string and have these two quotation marks around it, it's going to define this as string. And the way that we're going to change this is having the data type that we want to change. For example, we want to change a to the integer. So we got this int, and inside of this, we pass the name of our variable. And this time, if we run again, you can see again we got this str, because this is going to turn the 25, but this is not going to save anywhere. So we need another variable, aka another bucket, to save this value. And we want to save that in this b. And if we check the type of b right here, you can see if we run this time, this is int and not string. But pay attention, we can do the same thing with the a2. And when we do this, pay attention with the previous example, which we got 2 there and 5 here, the 5 is going to come and replace this 2. And when we do this, basically this is going to turn this 25 in quotation marks into simple number. So it's going to get this and convert this into simple 25 right here, and then it's going to replace this one right here. And that's why if we have this a right here this time, if we clear our output and run again, this time again we got this int right here. And as well as this item, we can have this with boolean values too. But here, instead of this int, we should have this bool. And now again, if we don't have this line right here, so if we comment this out, if we run, you can see we got class and type of integer. But if we have this part running and uncomment that, you can see if we run again, we got this type of boolean in our variable's type. And this method of changing the type of variable to something new from what it was previously is called typecasting. In this video, we're diving into input and output in Python. Basically, we're going to cover how to talk to your Python program and how it talks back to you. By the end of this video, you'll be able to interact with your users using print and input methods, two of the most essential tools in any Python program. Now this part is for our inputs and outputs. Let's start with outputs using our print method and function that we got see this in the previous part too. So we have this method and function right here that what we put inside of this parentheses is going to be shown in our terminal and output for us. For example, let's say here we're going to have our test example right here. If we run our program, you can see we got this words and this line right here. But in Python, we can print multiple arguments with simply one print function. And how we're going to do that? Let's say we have these two as separate two strings. First one is this test and second one is this example. if we separate these two items with this simple comma and run our program again, you can see again we got the same example and same result right here. Because by having this comma between of our items, Python automatically puts space between of these two arguments and prints that for us. And of course, you can have other values after this too. For example, maybe you want to have some numbers and some floats here after this. If we run again, you can see we got all of the things that we put right here in our output. And all of them has been separated by a space instead of this comma right here. But in Python, we can change this separator to be whatever that we want. For example, instead of the space, let's say we want to separate them with simple hyphen or dash. So for having that, we're going to put another comma at the end of our arguments, and then we're going to have this sep and equal that with the thing that we want to separate our items with. For example here, if we pass this hyphen right here, if we run again, you can see this time it got separated by this hyphens right here and not spaces. Of course, you can have anything that you want. For example, let's say we want to have this vertical bar as our separator. And this time, if we run again, you can see we got our items separated by our vertical bar. But another cool thing that we can do just like this is having another end parameter after these items. And how it works is having this end at the end and equaling that with something right here. For example, let's say we want to have these tuples at the end. If we run this, you can see when we got printing, after our final argument and item, we see these two items coming here. And pay attention, it's not going to separate from these items. It's going to attach to the end of our last item. And we got this right here. And of course, you can have anything that you want here. For example, let's say we got this word test. If we run again, let me turn on auto scroll. And if we run again, you can see we got the test attached to this one. But now let's say we want to have our simple string right here, which has this simple example inside of it. And let's say we want to have this dot right here, and we want to have our second example right here. If we want to run this, of course you can see it's going to run just like this in one line. But let's say we want to have this second one in different line. If we have enter right here, nothing is going to happen. And if we run again, you can see it's going to act like separator right here and show us again these two items after each other. But the way that we can do this is by having our new line magic, which is this \n. And by having this, if we run again, you can see it's going to come to the next line just like this. But let's say we want to have our second word in another quotation marks. You know, if we want to use this double quotations, it's not going to work because our whole sentence is in double quotations. Of course, we can use our single quotations here and this should work fine. But let's say we want to have this double quotations around our whole sentence and our word too. And for that, what we need to do is using this double quotation, but with \, before that. And by having this, again, this is going to be print. And now if we run again, you can see we got our second with double quotation marks right here, which we're going to talk about these symbols later in the course. But now let's make our program interactive. Well, we use print as our program to talk to us, and we need to use input to our program ask the user for information. What I mean is, let's say here we got our input and here we pass the message to our user to get response from the user. For example, let's say we want to have what is your name? And by having this, pay attention, if you run this in VS Code just like this, you cannot type right here in the output because this is read-only editor. And for having ability to interact with your terminal, you have to come to this terminal tab right here and run your program from here. We're going to come to the path that we're inside of it, which if you're not, you can come here in your directory tree and right click on your file and you have this open in integrated terminal. And if you click this, it's going to open the same path for you. And here you need to have your Python at the first and then name of your file, which mine is this main.py. And by having this, you can see we got this what is your name. And here if we pass our name right here and press enter, you can see we got this line worked, and then the second print line worked after this too. But if you pay attention, we don't do anything with this name that we passed here. So we need to save the user's response to some variables. And you know from the previous part, we're going to save the variables just like this. And by having this, we can use our name variable through our application after this line. And let's say here we want to have the name of our user print to the terminal. So again, if we run our program right here, it's going to ask for our name. Let's say we pass this Jack. And now if we press enter, you can see we got this Jack printed right here. But you know, we can use other things right here too. For example, let's say we want to have this hello and then separate that with comma and the name. And now if we run again, we pass the Jack again here. You can see we got this hello Jack right here. But let's say we want to ask the user's age too. So we comment this out by having our sharp here at the start of it. And let's have another variable right here, which again, we're going to use our input method and function here. And here, let's ask, how old are you? And now instead of this name, we're going to print simply this age into our console. And now if we run again, how old are you? Let's say we pass the number 30 right here. It's going to print this 30 for us. And if you want to clear your terminal here, you can use the simply CLS and it will remove the previous things for you. And now this time, let's use both of these two items together. So we're going to have this name and then this age. And after this name, let's say we want to print the name here too. So we got this name right here, then the age here. Now if we run again, which if you want to be comfortable with your terminal and not typing anytime, you can use up arrow and down arrow for previous and next command that you have put already in your terminal. And if you press your up arrow one time, you will get the last command that you put in your terminal. And if we run this, it asks us, what is your name? And if we pass this Jack here, it's going to show Jack for us and ask us, how old are you? And here we pass this 30. And this time it's going to print this 30 for us too. And of course, we can use these name and age together in one print. And here we're going to have this name, separate that with this comma. Then we're going to have string here, which is, and then the age, of course. And at the last, we're going to have this years old. And now again, if we repeat the work that we done, we got this Jack, we got this 30. You can see we got this Jack is 30 years old. But let's say we want to add one number to person's age right here. If we use this +1 right here at the age and run our program, the name is Jack again. But if we put this 30, for example, you can see we got this error. And that is error because our age here is string and not number. Pay attention from the previous parts, we got our type method that we can use. And here in our print, let's say we remove these things here and have this simply type. And then we check the type of this age. If we run our program and fill the name part, and then for the age, if we pass only these numbers, it's going to return the class of string for us again. Because no matter if user types a number, it comes back as a string. And of course, you know how we can fix this item. We can have this age1 variable right here and equal that with int version of our age. And now this time, if we clear our console again and run our program again, if we fill this, and actually we need to make this age1, so we use Ctrl+C right here. Again, we run our program, the name is Jack still, and the input here is 30, and this time you can see we got this int right here. and we can modify anything that we want right here. And of course, now you can have your name right here and separate that with comma, and here we're going to have our h1, and this time we can add some values to this item too. So if we run our program again, the name is Jack here, and here we pass this 30, and it's going to add this 5 to our 30 and show us this 35 right here. But you know that we got this method of showing and merging several things with each other with print. For example, let's say here we're going to have this user's name is, then we're going to end this string, have our variable right here, then have another separator here, then we're going to have another string, and this time we're going to have and he has, then our age with its comma, and after this another one, and this is our years old. But you can see this is a little bit messy than what we used. So instead of this, we can use another awesome formatting called f-strings. And how it's going to work is simply we start our string with f before of our quotation marks. And we don't need several strings for this, so we're going to get rid of this separator and this double quotations as well as here and here too. And when we want to use the variable, what we do is simply having this variable's name inside of this curly braces. And as well as this, we can use that for our age too. And this time, if we run our program, we pass our name here and then our age here, and after we press the enter, you can see we got our result right here as well as the last syntax, but this is more efficient and better to use, and it's very clean and readable. So in this part you learned how to use print to display information to the screen, how to use input to get user inputs which return us always as string. You can format outputs with sep and end at the end of your print with multiple arguments, and you learned how to convert your inputs from string to numbers when you want to add something or subtract something from that number, and you learned how to use f-strings in your print and outputs. In this episode, we are diving into the power of arithmetic and comparison operators, the building blocks of logic and math in programming. You'll learn how to do calculations and compare values in Python, skills you use consistently from small scripts to full applications. The first thing that we're going to have is our arithmetic operators, which these are simply our math operators that we got in every programming language. So for a start, let's say we got our variable of a, which has this number 2 inside of it, and then the variable of b, which has this value of 3 inside of it. And we're going to have our print right here, which let's say we start with printing a right here, which if we run, you can see we got this 2 as our a. Now let's come into the operators that we have, which the first one is addition, which is going to be this a plus this b, and it simply adds these two numbers together. And now if we run, you can see we got this value of 5 here. Then the next one is going to be subtraction, which if we have this a to be, for example, number 8, and subtract this b from a right here, so if we run this, we got this value of 5 here. Then we're going to have our multiplication. Now if we have again this 2 right here and have our star right here, it means the multiplication. And if we run this, of course, we're going to have this 6 here. And the next operator that we have is division, which let's say here we got our 6 and we want to divide the 6 by this 3. So we use this slash for that. And now if we run, you can see we got this 2. And pay attention, this always returns float value, even our numbers are not float. So if you want to remove this decimal, pay attention, you need to use this int here, so you get rid of this decimals. And this time if you run, you can see you got the simple 2 right here. But you can do the same thing that you got right here by having double slash right here. Pay attention, single slash is going to give you the float number, but if you have this double slash and run, you got the integer and whole number right here. Then we got another remainder in programming, which let's say we want to divide 7 by 3, which if we want to get the integer value, you can see it's this 2. But if we want to have the remainder of that, we're going to use this percentage symbol. And this time if we run, you can see we got the 1. Of course, we can have the 8, and this time we're going to have this 2. And then after this, we're going to have our exponentiation, which is double stars next to each other. And of course, if we have this and run, we got this 8, and this simply means 2 by the power of 3. And if we want to have summary about what we have just did, this is the full summary of our thing, which if we got A as 2 and B as 3 and run our code, this is our results. We got the addition of 5, subtraction of -1. Pay attention because we subtract B from A, and because 3 is bigger than 2, we got this -1 here. Then we got this multiplication, division, and other values just like as you see right here. But now let's talk about comparison operators, which these compare values and return either true or false, which are perfect for decision and conditions. And what I mean from that, let's say this time we got our A to be this number 5 and B to be this number 3. And for this, we're going to again print our numbers with some operators. But this is a little bit different operators. We're going to have our numbers and variables, but between of them, the first one that we're going to check is equal to. And that's by having two equal signs next to each other, which this is going to tell us if A equals to B. If that was true and A equals to B, it's going to return the value of true for us. But if those are not equal, it's going to return the value of false for us, which in this case, we should get the value of false. And if we run, you can see we got the value of false right here. But let's say we got both of them to be number 5. And this time, again, if we run, we got the value of true. But here we got this number 3 here. The next item that we got is not equal to. And what this means is opposite of this. And by having this exclamation mark and this equal sign next to each other, we got this result. And this is basically opposite of equal. So in equal, when we got true, it's going to be false. And when it's false, this is going to show us the true. So because A is not equal to B, so we should got the true value right here. And if we run, you can see we got the true. But if these two were equal, if we run again, we're going to see the result of false. So pay attention and basically remember this 3 lines that we got right here. If we got true in equal, we're going to have the false in not equal. And if we got false in equal, we should have true in not equal. After this operator, we're going to have our greater than and less than sign. Let's say again our B is 3 here, and we want to check if A is greater than B, which we use with this greater than sign. And of course, based on our numbers, this is true, and if we run, we got the true value. And if we want to have the opposite of that, it's going to be false, and if we run, it's going to be false here. And pay attention, if these two are equal, if we run, we got the false value. But if we want to have the greater than or equal comparison right here, what we need to do is having our greater than sign right here, then the equal sign next to that. And by having this, it's going to return us true if A is greater than B or equal to B. For example, in this case, it's equal, so we got the true value. But let's say if A is number 8, again, we're going to get the true value. And the only time we get the false value is when our B is larger than A. For example, here, if we run, you can see we got the false value. And of course, we got the opposite of that, which is less than or equal, which in this case, we only switch and flip the greater than sign with less than sign. And this time, our rule changed. And the only way that we got false from here is having a bigger than b. And here, if we run, we got this true. If both is going to be a, again, we're going to have this true. But if our a is going to be, for example, 10 right here, and run, you can see we got the false result. And if we want to see summary of what we learned together in this part, this is all of them in one place. And if we got our a as 10 and b as 8 and run our program here, you can see we got this result right here, which these are not equal, so equal is false. Not equal is opposite of this, so it's going to be true. Greater, yes, because we got our a greater than b. Less is false, greater or equal is true, and less or equal is false, based on this comparison right here. And these are super useful for making decision in code, and you will see them again when we learn if statements and conditional programming, which these are essential tools you'll use consistently on your coding journey. In this video, we're going to talk about making decisions in our code with if, else, and elif statements. Let's start with the most basic control structure, the if statement. And the way that we're going to have is by having our if statement right here, then we're going to have our condition right here, and this double columns, and under this, but some space inside of this if, which means we are inside of our if block, so we're going to have our code. For example, let's say we're going to have this print of our test word. And here in this condition, the value must be Boolean. So we can have this static value of true for our test and start. And if we run, you can see we got our test. And if this is not true, this is not going to be printed. So if we have this as false, for example, and run our code again, you can see this time we don't have any outputs right here. And you can use your comparison operators, which we have learned in the previous parts, and you can use them right here. For example, let's say here we're going to have our simple variable, which holds the value of 40. And here we want our if statement to check if a is greater than 50, print this test. And if we run, because it's not true, and this comparison returns false value, so we don't have this. But if we change this to if a is less than 50, because it's true, so this returns us true value, and if we run, you can see we got our test word printed right here. But pay attention, if you don't have this spacing right here, it's not going to recognize as inside of this if. And you can have multiple prints right here. For example, let's say here we have test 1, test 2, and going on. Let's say we have another test 3. If we want to have all of them print with this condition, and if a is lower than 50, of course this is going to run and we got our results. But if we don't follow this rule of being inside of our if block, and for example, let's say our first one is here but not the others, if we run this time, you can see all of them run like this. But if our comparison has the value of false instead of true and run, you can see we got our test 2 and test 3 running, because these two are not inside of our if statement. So if we want to have them, we should get them inner in our code with some spaces, or basically you can use one tab. Now let's handle what happens when the condition is false. That's where our else comes in. So we have this print, let's fix this. We got this a is bigger than 50. And we want to tell if this is not true, run the other code. If we have another code right here, for example, this print of a is less than 50, if we run this, you can see we got a is less than 50 in this situation. But if we got this to be, for example, 60, and we got a bigger than 50, if we run again, you can see we got both of them printed right here. And to fix that, we're going to have simply this else right here, then another double column, and we move our print of a is less than 50 into our else block. Pay attention, our else don't have any conditions, and this is based on this condition. Again, if this is true, this is going to be run, and if this is going to be false, this is going to run for us. And now this time, if we have a to be 60, if we run, you can see we got this a is bigger than 50. But if we have this one to be, for example, 40, if we run again, you can see we got this a is less than 50. But let's say we want to check more than one condition. And for example, we want to have our score here as our a. So here we're going to have our score. And based on this number, we're going to pass and print the grade that it belongs. For example, if it's above 90, we're going to print grade A. If it's above 80 and lower than 90, grade B. Above 70 and lower than 80, grade C. And below 70, grade F. And to do that, what we can do is having our score here in our comparison and check if it's bigger or equal to 90. And if it's true, we're going to pass the grade of A. And here in the else part, we can have another if statement. And pay attention, this is another code that it can run. And here we can check if score is above or equal to 80, then we want to print grade B. Pay attention, because here we got another if statement. This is the space that we need to be inside of this else. So we should have this right here. But because we want this print to be inside of this if, we should have another spacing right here too. And by having this, we can check. For example, let's say we got the score of 95. If we run this, we got this grade A. If we have this value and score of 85, if we run, we got this grade B. But let's say we have multiple of these type of else, and inside of that another if, which having another thing. For example, let's say here we're going to have this else again. This time we want to check if score is equal or greater than 70, and we want to print this grade C, and another else here. And this time, because we checked all of the other values that we got, this means here we don't need any comparison. If it's below 90, it's going to come here. If it's below 80, it's going to come here. And if it's below 70, it's going to come here. And we want the values and scores below 70 to have this simple grade of F. And now here we can come and check our code. If we run this 85, you can see we got this B. If we have this 75, if we run again, we got this grade C. And if we have this score of 55, if we run, you can see we got this grade F. But this is very messy to maintain. And we have another thing which is very good and very useful in programming for us, which is our elif statement. And what that is, it's basically going to do the same this thing, but in one line and very clean. And for that, what we need to do is we need to have our if and else in the same line and simply remove these items. So we got our elif, then our condition and our block of code. And we can do that with all of these items. So we have this elif right here, as well as this else right here at the end. And here, pay attention, we can use else with the elif too. So we're going to have this kind of syntax right here. We got our score right here. If it's above 90, we're going to have grade A. If it's above 80, we're going to have grade B. If it's above 70, we're going to have grade C. And otherwise, which is not above of 70 and all of these other items, it means it's below 70, and we can have this print of grade F right here. But let's come back to our simple if statement here and talk about how we can combine multiple conditions with each other. For example, let's say here we got this age here, which is going to be, let's say, 30 right here. And we want to check if our age is above of 18. So we got the simple print of you are adult. But let's say we want to check if the age is in some range between of 18 and 40. And for that, we can have another if statement. Inside of this if statement right here, we're going to check if age is below 40. And then we want to print that you are invalid range. And here, if we run, you can see we got this result. But if we're going to be, for example, 15, because this is not going to be true, so we don't have anything printing right here, which we can have some else here too. For example, for this, let's say we're going to have else. We have again this print and you are below the range, and we can have another else for this if too. So we got this else, and here again we have this print, and here we're going to pass this string of you are above the range. And by having these controls here, if we run again, you can see because it's 15, we got you are below the range. If we got this to be, for example, 55 and run again, you got this you are above the range. But another way that we can do this is very cleaner, and we can combine these two conditions with each other. And the way that we're going to do that is, let's remove this second comparison for a moment, and here we're going to have this and pass our second comparison, which is going to be this age below 40. And again, if we are 55, if we run, we don't have anything. If we are 15, if we run, we don't have anything again. But if we are, for example, 25 and run, you can see that we got this printing of you are in valid range. But what this AND does? These are basic programming combinations. In Python, we got 3 different combining things that we can use, which are AND, or, and not. And what those are, AND is like this. If our first condition is true and our second one is true, then our third one and our result is going to be true. Otherwise, it's going to be false. So for using and having true, both of them should be true. But after that, we got this OR, which in that we only need one of 2 statements or conditions to be true. If we got both of them true, we got the true result. If we got one of them true and other one false, it's going to be true again. And the opposite of that, the first one false and second one true, again we got this true. And the only way that we got false results in OR is by having both of them to be false. And you can see, because we use this AND, this is going to give us this result and print this if both this and this is going to be true. Which means if we got this true right here, and again this true, it's going to run for us. If we got one of them to be false and run, this is not going to print anything for us. But if we got OR instead of this AND right here, if we run, you can see again we got this print, because in OR we need only one of these 2 conditions and Boolean values to be true. And the last one that I mentioned is our NOT, which we can use this to simply reverse the result. So let's say we got this if age is above 18 again. And here we got this you are adult. And if we don't have this NOT, if we run, you can see we got you are adult because age is 25. But if we have this to be 15, for example, if we run again, we don't have anything printing because, of course, 15 is not bigger than 18. But if we got this not right here, it's going to reverse the result of this comparison. And this time, because 15 is not above 18, so this has the value of false, but not is going to come and make the value of this the true. And if we run this time, you can see again we got our result using our not. And you can use this to check some things in your systems. For example, let's say you got some applications that you have this variable of logged in, which is going to be, for example, false at first. You can check if not logged in, then print you need to log in first. You can do the same thing with other things. And now if we run, you can see we got this you need to log in first. But if this was true, of course, we don't need anything to be printing here. But Pay attention, you can do the same thing and same logic with other syntax too. You can check if login equals to false, then print this. So if we run again, we got this result. But if we use not, it's very cleaner and very easier to maintain. So in this part, we learned how if statements execute code when a condition is true, while the else handles the opposite case. You can use comparison and logical operators to build powerful conditions that you can merge the comparisons with and, or, and not too. And as well as these items, you learned how Python block works, which some space before of our line starts, which make this line inside of the block of the line above it. In this part, we're talking about one of the most powerful tools in programming. You will learn how to repeat actions using while and for loops, essential for tasks like processing lists, taking inputs, and automations. Don't forget to subscribe to the channel to be aware of next videos, and let's dive into the video. Let's start with our while loop, which repeats a block of code as long as a condition is true. And the way that we're going to use that is having our while word right here, then our condition right here. For example, let's say for our condition, we got our simple variable of number right here, which is this 5. And we want this condition and comparison of if number is below 10, we want to run the code below. And pay attention, we got our columns right here. And then when we want to come to inside of while loops codes, we need to have one block space inside of our line. So by having our code right here, it's going to run in our while loop block. For example, let's say at the first, we want to have our print of this number that we got at the top. If we run this, you can see we got printing these and it's going to run forever. But we don't want such thing because it will never stop, and it's basically what we call it infinite loop. Always make sure your loop has a way to stop or you'll get stuck in an infinite loop. And the way that we're going to do that is having our number to increase each time when our code runs. So we got our number plus 1 and save that in the same number variable. And this time, if we run our code, you can see it runs only 5 times and from 5 to 9. And this is how it works. First time it comes, check the condition, it's true, so it's going to print the number which is 5. Then it increases that to the 6 and check again. This time again the condition is true, so it prints 6, then comes and adds 1 to that number, check that, print that, so we got 7. Again it's going to do the same thing and print 8, and after that it checks this is 8, so prints, and after adding one number to the 8 it's going to be 9. This time it's checked and again it's true. It prints the number, but when it adds 1 to that number it's going to be 10. And when again our condition is checked, our comparison returns false value. So our 10th number is not going to be printed because of our comparison. If we have this less than or equal and run again, you can see this time we got our 10 right here. And pay attention, you can have any variations that you want. For example, we start from 0. Let's clear our output, and if we run again, you can see we got printed numbers from 0 to 10. And of course, you can have some other comparisons here too. For example, let's say we got this variable of a here, which is 5, and we want to check while number is less than or equal 10 and a is greater than 5. And this will check both of these and these one. And if you remember from the last part, we got this and, or, and not that we can use. And this time, let's say we want to decrease 1 from our a, so a equals a minus 1. Pay attention, you can do the same thing that this line does with the shorthand that we got, which is this plus and then this equal sign, which this adds 1 to the number that exists in this variable. And we can do the same thing with our a, but this time it's the minus then the equal sign. And let's actually change this 5 to this number 10. And let's on our printing, we say this number and have A right here and print our A2. And this time, if we clear our output and run again, you can see at the first our number is 0, our A is 10. It's going to come to the next loop and next time of running, and this time number is 1, A is 9. And it's going to come until one of them is not true. You can see here we got our number still below 10. But because our A is above 5, it's not going to run anymore. The next thing that we're going to talk about is our for loops. Fors are something like a whiles, but we got some more controls on them. And for a start and having that in our code, what we need to have is having our for word right here. Then we need to create variable for this for loop, which the popular variable for this is this I. And then we're going to have this in and our range method and function right here. That we pass some number right here, and our I is going to start from 0 and comes until this number that we put right here. For example, if we put this 5, this line is as same as we have this variable of I, which starts with 0, and then have our while loop and have the condition is I smaller than 5. But this is more compact way that we can have this. And if we simply print our I right here into our output, if we run, you can see we got numbers from 0 to 4. Of course, you can have any numbers that you want. For example, let's say we want to have this 50, but pay attention, in 4, we don't need this increment level for the I, because it's going to do that for us automatically. And now if we run this one right here, you can see it got printed from number 0 until number 49 right here. And of course, if you want to have number 50 here, you can either have this 51, or for simple visibility, you can have this 50 plus 1 right here. And of course, this time it's going to run until number 50. But the cool thing about this range is we can have multiple parameters right here. For example, at the first, let's say we got this number 10. If we run our code, you can see we got 0 to 9 right here. But if we have two parameters right here, and let's say we want to start with number 5. If we put number 5 right here, then number 10 right here, if we run again, you can see it starts from number 5 and not 0. So it's going to come from number 5 to the number 9 right here. But we can have another parameter right here, which is our step. And it tells us how the incremental thing that we got is going to work. At the default and where it's empty and we not pass our third parameter, it's going to be number 1. As you can see, it's 5, 6, 7, 8, and 9. But if we have, for example, 2 right here, if we run again, you can see this time each loop adds 2 to the I and not 1. So we got this 5, then our 7, and then our 9. And of course, if we have some larger number, something like of 100, we can have some steps like 15 right here. And if we run this right here, you can see it starts with the 5 because we passed 5 here. Then we got 20, 35, 50, 65, 80, and 95. And because after this, it's going to be 110. It's not going to be lower than 100, so it's not going to be run. You can use loops to automate repetitive tasks, handle inputs, and process data that needs to repeat some part of the code. In the last part, we learned all about loops. Now we'll dive into how to control those loops using 3 powerful keywords: break, continue, and pass. By the end of this video, you'll know how to skip, exit, or handle loop logic like a pro, and you'll understand when to use each one. The first thing that we need to have is having some simple loop. For example, let's say we got our for loop and we got our number right here, and we got this range to be from 1 to number 10. And if we simply print this number into our output and run our code, you can see we got printed numbers from 1 to number 9. But here we want to use break, which is a tool that we can use to exit a loop early. Break is used to immediately stop a loop when one of the loop conditions that we pass right here is true. So let's say here we want to break out of our loop when the number is 5. So for that, what we need to do is having our simple if statement right here. Then we want to check if the number equals to the 5, then we want to run our break right here. And by having this, it's going to start running from number 1, but because this condition is not going to be true, it's not going to come and run this line, which is our break, until this number reaches number 5. Then this condition is going to be true and it comes and breaks the loop for us. And if we run, you can see it comes until number 4 and then it stops because our break word runs right here. And pay attention, any code after that break inside the loop is not going to run. So it's 5, it breaks, and it's not come and print the number 5 again. So this break stops all of the loop just when that runs. And of course we can have the same thing with the while too. So let's comment this out for a moment and have our while loop right here. So we want to have this while true, for example. And let's say we want to have some input. For example, we want to have this variable of a, which we got this input, which has this type word right here. And then we're going to print that a simply into our console. And here, if we want to run our file right here, so because we got input, we cannot use this extension. We need to run that in our terminal. So we use this Python main.py. And if we run, you can see we got our input. For example, if we have this test, if we run, it runs, prints that for us, and again comes right here. And we can have anything that we want, and it's infinity loop and runs forever. But from the last part, you know that we need to wait to get out of our loop. And the way that we're going to do here is having our a checked for if a has the value of exit. And if it has that, we're going to break out of our loop. And this time, if we run again, we can have anything that we want right here. But as soon as we put this word of exit, it's going to go out of our loop. And this is the way that you can control your inputs and while loops using break. Now again, let's comment our while loop and come into our for loop. But this time, let's talk about the continue statement, which this skips the rest of the loop's code just for the current iteration and current time of running the loop. So the loop does not stop, it just jumps to the next round to run. What I mean is, here you can see if we run, it's going to run until number 4, and at the number 5, it's going to stop the loop. But if we have this continue right here, if we run, you can see it comes, but it skips the number 5 and runs 6, 7, 8, and 9 after that. Pay attention, when we got this continue, it seems like we don't have anything after this continue. So it just seems like this at the 5 iteration and when our number is 5. But for the rest of them, it's going to be still this print of number coming into our output. And of course, you can use that with the while loop too. For example, let's say we got again the last example, but this time we want if it's this word of pass, it continues and not printing that to console. So let's clear our console and run our file. We can have anything that we want, but as soon as we use this pass, it's not going to print anything for us and it's going to ask another word from us. And of course, you can use both of the continue and break together. So here, if we have this exit, it's going to break, and if we have this pass, it's going to continue. So if we run our program again, we can have anything that we want. If we have this pass, it's going to pass the printing for us. And if we have this exit, it's going to exit from our program. But as same as this continue that we got right here, we got another thing, which is statement of pass. And what this does is this statement is simply a placeholder statement and does nothing. Literally, it's a placeholder when you need a block of code syntactically but don't want to run anything. For example, let's say here we got pass instead of that break. If we clear our terminal and run our file again, if we have our test and then have our pass, if we run, you can see it got the word of pass, but this does nothing and still runs the rest of the code for you. And if we want to check in the for loop, so we come into the output, clear our output, and here if number is 5, we want to pass. And if we run, you can see this time we got this number 5 to pass. This is as same as we don't have anything right here, just like this. So if we run, it runs all the way from number 1 to number 9. But if we got this one right here, it means we want to do something when the number is 5, but we have not coded that part yet. For example, maybe we want to have our break, continue, or other things and functions coming up, but we haven't written that part yet. And instead of having it blank and causing an error, because if we have this empty, you can see we got some error, and if we run, we got some errors right here. So we use this pass to avoid syntax issues. And you can use this pass in the functions and classes too, which we're going to talk in the next parts. So at the end, this is the recap of this part that we got. We got our break, which exits the loop for us. Then we got our continue, which skip the current time of running and continue. And at last, we got this pass, which is just a placeholder for avoiding syntax errors. Knowing when and how to control your loops make you much more flexible programmer, and by learning these, you just mastered how to stop, skip, and structure your loops in Python using break, continue, and pass. In this part, we're working with one of the most important data types in Python, which are strings. Through this part, you'll learn how to access, modify, and format text using Python string features. As you know from the previous parts, we got our variables and we got several data types, which one of them is our strings. Which strings can be in two formats of this single quotations or this double quotations, which doesn't matter which one to use, and you can use either single or double quotation. And basically, you can think of a string like a list of characters. Each character has an index starting from 0. What I mean is, think of this as one list starting from here to here. Think of we have a list like this that we got S here, then our T, then the R, and going on. And each one of these has its index, and index is basically a label for their place. And in programming, all of our indexes starts from 0. So our S is at index 0, T is 1, R is 2, 3, 4, 5, and 6. And by having this, we can address each character inside of these strings. And just as same as we got this indexing which starts from this S right here, we got our negative indexing. And those are exactly in the opposite direction. But pay attention, that one starts from -1. And this is the way and basically a map for our characters in our strings. But what are the usage of these items? For example, let's say we want to have our simple print right here, and inside of this, we want to print only the first character of our string. So we got our variable's name, or we can have this variable's name as this text, for example. And then we have these brackets, and inside of this we can have any index that we want, and it's going to grab the character at that index and print that for us. For example, let's say here we got this character of 0. If we run our program, you can see we got this S right here, which is this one. If we got, for example, this 2 here and run, we got this R because S is 0, T is 1, and R is number 2. And of course, we can have our negative indexing. For example, if we got this -2, because our minus indexing starts from -1, so S is -1 and G is our -2. And if we run, you can see see we got our G printing into our output. But in some cases, we want part of our string to print and not only one character. And to do that, what we have is our slicing. And for that, we basically have our starting character. For example, let's say we start with character 0, and then we put these columns, and then we put the index of end character after this. For example, let's say here we put this 4. 0 is this S, T is index 1, R is index 2, 3 is this I, and 4 is this N. And if we run, you can see we got this STRI. Pay attention, our number 4 index which we put right here is not going to be print. It's going to start from what we put. This is going to be in the string and the slice until this one. So we don't get the N and we only get indexes from 0 to 3. And of course, we can change this, for example, to start from this 2 until 4. If we run, you can see we got that. But in cases you want to start from index 0, you don't need to have this. You can basically leave this empty and it still works. And if we run, you can see we still got this STRI here. Or we can do the opposite thing right here. For example, we start from index 3 until the end, so we don't put anything here. If we run again, you can see we got the result just like this. Basically, the format is we have our string, then we got our brackets, then we're going to have start here, and then our end here. And this is incredibly useful when you need to extract parts of a string like first names, domains, or file extensions. But now let's talk about the common methods that we got in strings that we can use. Which for that we need our variable's name right here, then we put this dot and the name of our method. For example, the first one that we got is this upper, which if we have that upper word, then these two parentheses right here, and run our code, you can see all of the characters inside of this string turns into the uppercase. It doesn't matter it's lowercase. For example, let's say we got this R as uppercase. If we run again, you can see we got all of them in uppercase. And we got exactly the opposite, which is this lower. And if we run this, you can see all of the characters has turned into the lowercase. Pay attention here, we got this R as uppercase, but when we printed that, we got this R as lowercase in our output. The other thing which is very useful that we have is our capitalize. As it shows from its name, it's going to capitalize our string for us, so it's going to make our first character uppercase, then the rest of that lowercase. But if you have something after this, for example, we got this test, if we run this, you can see we got our first word's first letter and character uppercase, but not the second one. And for fixing that and make all of the words have their first character to be uppercase, what we need to do is we can use our title method. And by this, you can see we got all of each word inside of string to be capitalized. The other part that we're going to talk about is our searching inside of our string. You see here, we got our string test right here. Let's actually fix this capital R right here. So we got this string test. And let's say we want to find the word of test inside of this string. So we got this find method right here. And inside of these parentheses, we simply pass the name and the word or series of the characters that we want to find. Let's say here we want to find this test. Pay attention, we should make this string and pass string to our find method. And now if we run, you can see we got this number 8 printing. But what is this 8? If we check our string, you can see we got our index like this. We got our 0 for S, 1 for T, 2, R, and going on just like this until this T, which is our index 8. So our T is index 8. So it's going to find this word, which is this test right here, and returns the first character's index that it starts. For example, if we have this ESD instead of that, if we run, as you can see, it's going to return us the index of 9. Because this E starts from 9 as well as this set of characters starts from 9. And if you have something which is not in the string and if you run, you can see you got the value of -1, which means this text is not inside of our variable. But in some cases, we only want to see if there is this text or not. We don't want to have the index of its start. And for checking that, we need to have our word. For example, let's say we want to have our test to check if this test word is inside of this text. And for that, we simply have this spaces and then this in. So we got our word that we want to find, then one space, word of in, and then another space, and our string that we want to search our word inside of that. And now if we run, you can see we got this value of true instead of that indexing. Pay attention, in the previous part and previous find method, we received the index of 8, but this time we received only this true. And of course, if we have one thing which is not inside of this, for example, this random set of characters, if we run, you can see we got this false result coming into our output. But if you want to change the output and reverse that, of course, you can have this not, which we talked about this not in the previous parts. And this is basically reverse the output for you. If it's inside of text, it's going to return false. And if it's not inside of text, as you see in this case, it's going to return true for you. In this next part, we're going to talk about white space and replacements. Think of this way, we have our string with some spaces before of that and some spaces after that. And of course, some space between of our words. If we print this normally as we do, you can see we got all of those items printing into our console. We got the previous spaces, the last and the end spaces, and space between of these items. But if we want to have only this part and remove the spaces before and after of our text and word, what we need to do is simply having this strip method. And if we run this right here, you can see this time we don't have those spaces and we have only our characters, but we got the spaces that we have between of our words. And pay attention, if we have several spaces here, if we run again, you can see still we got those items right here. So the strip method is only going to get rid of the spaces before and after the first and the last character that we have. Now the next thing that we're going to talk about is, let's say we want to replace this test with some other words. For that, we can do that manually, of course, but think of this way that we received this from somewhere like input or maybe from some APIs, and if we want to change that, we should do that with our code and dynamically. And for that, we got our method of replace. And by having this is going to grab and take two strings from us. First one is being the word that we want to replace. For example, in this case, we want to replace this test. And then we're going to separate this with another string and word, which this word is the word that we want to replace the previous word with this one. For example, let's say we got this new one to be the simple Python right here. If we have this means in the text, replace word test with the word Python. So basically, it's going to grab this Python right here and replace this just like this. So if we run this, you can see instead of having that string test, this time we got this strings Python. And that's because our replace method worked and replaced test with Python. Pay attention, all of these methods are going to return that thing and that output for us. And if we not printing that and have that statements just like this, as you can see right here, and then we simply print our previous variable, which is our text right here. If we run, you can see it's going to be the same string that we got earlier. So this is not going to change the original string and variable that we have. It's only going to do this thing and return that for us. But if we want to save this and use later, we can do simply this text2 variable, for example, and have this and then print that. And this time, if we run, you can see we got new value, or we can save this text and update that here and give this new value just like this. And this time, if we run, you can see again, we got the same result and new string. Now, for the next part, let's talk about how to build dynamic string using variables. For example, let's say here for our string, we got our simple name, which is this Jack. And we change the name of the variable to this name. And let's get rid of these other lines that we got right here. And now let's say we want to print the simple statement, hello Jack. For that, as you know from earlier parts, we got this print. We have our string of hello, then some space, and we add that with our name. And if we run this, you can see we got this result of hello Jack right here. This is basic concatenation that we got in programming. But another and very better way of doing this is by using our f strings. And those are simply, we got our string at first, but we have another f before of our string. And then we can have all of the strings that we want. For example, in this case, we want to say hello to our user, which this one, we want this to be dynamic. And then maybe we want to have some other phrases or sentences right here. For example, let's start coding. And now for having our variable here instead of this user, what we need to do is having these simple curly braces and then put the name of our variable right here. You can see by only having this, if we run our code, we got this hello Jack, let's start coding. And this Jack came to here and inside of our string dynamically. And pay attention, with this f string, we can have several variables and not only one. For example, let's say we got another age, which is this 30, for example. And here, instead of having this sentence right here, let's say we want to have the name of our user. Then we want to tell is age years old. And now if we run, you can see it still works with this dynamic importing. But the older way of this f string, which you might see in some older codes when you're maintaining some other projects, is our format method, which for that we got our string at first, and after end of our string we got our format method right here, and inside of this we pass simply the variables that we want right here. But pay attention, in this format we don't put the names of the variables right here. So these must be empty curly braces just like this, and then we fill that in order right here. So because it's order sensitive, the thing that we put at the first is going to go to the first field, and the thing that we're going to put after that is going to go to the second field. For example, in this case, we got our name at the first and age at the second. And this time if we run, you can see again we got this result right here. But if we got that wrong, so we got our age at the first and then name, which is wrong. If we run, you can see it's going to mess our sentence. So f string is very better way to controlling and not having this kind of issues, but this is something that you might see in other codes. And of course, you can use all of the things that we have learned here together. For example, let's say we got some input for our name. So we got this input of enter your name. And then we can have this age, which is another input, let's say. And this time here, we want to have this enter your age right here. And after we receiving this, we want to strip the name. So for example, let's come into the terminal first and let's run our code. Pay attention, when you want to use inputs in Python, you can't use this extension and you should run your file from the terminal. And now if we run this, it says enter your name. Let's say our user has accidentally pressed this space several times and then has this Jack, for example, and another spaces, and then his last name, for example, let's say Smith right here, and some other spaces right here. And after this, for the age, let's say user has 30 years old. So we got these inputs, but let's process that and make that good in our, for example, welcome phrase. And let's say here at the last, we got our print of simply this f string of welcome to our user, which here we need to have the name. And then we can have some little parentheses here and tell the age of the user right here. So we got the age right here. If we do the same thing that we got earlier, we got some spaces, Jack Smith here, some other spaces, then the age. You can see this is not good output and welcome message to show, so let's fix this. For that, we're going to use our fixed name variable for saving the results that we're going to do. And the thing that we're going to do is simply having our name variable right here. Then we're going to strip this so we get rid of the spaces before and after our actual input string. And let's say we want to have these words to be capitalized. And if we want to do that to both of these items, we can use .title. And we can use both of those methods one after each other. So we use this title right here, and just by having this items and changing this name to the fixed name, if we clear our console and run again, let's say we got some spaces, then the Jack and this Smith right here and other spaces. Let's actually make this lowercase, some spaces here, and then this 30 for the age. And now if we hit enter, you can see this time we got string that we want, which has no extra spaces, and both of the first name and last name are capitalized, which we use strip to get rid of the spaces, and title to have these first letters to be uppercase. In this part, we're diving into lists, one of Python's most powerful and flexible data types. By the end of this video, you'll know how to create lists, access their items, and use Python's built-in methods to work with them efficiently. Don't forget to like and subscribe to the channel to be aware of the next videos coming up. Now let's dive into the video. First question that we have is, what is list? Well, list is an ordered collection of items that you can store numbers, string, or even other lists. And the way that we're going to have those is very similar to variables. For example, we have this list 1 here, and we equal that with this square brackets. And the items that we want to be in our list are going to be inside of these brackets, and we're going to separate them using commas. For example, let's say at first we want to store some numbers in our list. So we can have any number that we want, we put comma and separate that from the other one, and we can have any number of items that we want. And let's say we want to have another list 2 here, but this time instead of having numbers, we want to have some names, for example. Well, we can have this Jack, then we separate that with another one of Tom, let's say, and we can have another one of John, for example. And of course, you can have some list which contains both of the numbers and strings. So let's say here we want to have this Jack as our string right here. Then we want to have some simple and random numbers. Then we want to have another Tom right here. And after this, we want to have another several numbers too. And all of these are going to be valid in Python. The other thing that we're going to talk in our list part are accessing the items. Just like strings that we accessed our items using their indexes, here we can do the same thing too. So for having some simple idea of how our indexing works, here we got our Jack to be in index 0, then this number at index 1, the next one 2, 3, 4, and going on. And pay attention, we have this negative numbers too, that we can work with them too. So these are our regular numbers and indexing, and here we're going to have our negative ones. And it's going to start from the last and come to the first one. So this one should be -1, then we have this one to be -2, and coming until right here, which this one should be -9. Pay attention, because we start from 0, this one has the index of 8, but in the negative, when we starting from here, it starts from -1, so this one is going to be -9. Now let's print some of our items into our console. So for that, we're going to have our simple print statement right here, and then inside of this, we're going to have our list 1 right here. If we have the simple list 1 and run our code, you can see we got our list printing just like this into our console. No extra things, no some other separations, just as you put that. But if you want to access one part and one item inside of your list, what you need to do is again having this square brackets and write the index that you want. For example, here we're using list 1 and this is our list 1. And here, let's say we want to print this number right here. So for having this is our index 2, 0, 1, 2. And here, if we put this 2 simply right here and run again, you can see we got our number printing into our console. And of course, you can do negatives too. So if we have -2, -1, and -2, if we run, we should get this number right here into our output. But pay attention, here in our list, we got our slicing work too. So let's say we come into the list number 3. So we make this 3. And here we want to print from here until here. We don't want these ones and these ones. So we want from index 1 until index 5. And for that, we pass this 1, then this columns, and pay attention, if we want our index 5 to be in our printing, we should put index number 6. And after having this, if we run, you can see we got our result sliced out of our list number 3. But another thing that we got in lists which are very awesome is our ability to modify the items. And for that, let's have our simply print of one of our lists, let's say our list 2, into our output. And if we run this, you can see here is our output. And here above of that, let's use and modify one of our items inside of the list. So let's say we want to change this Tom to Tim. And for doing that, what we need to do is accessing to our list 2 and the index of this, which is index 1, and then we equal that with the new value. For example, in this case, it's going to be 10. And by having this, if we run our code, you can see now instead of Tom, we got this Tim in our output. But pay attention, when we do this Tim is going to replace the Tom, and Tom is not available anymore. But in some other case, we want to add this Tim into our list and still have this Tom in our list. And for doing that, what we can do is using our append method. And the way it's going to work, here we're going to have our list name right here. Then we have this append method. And here we're going to have the new value and new item that we want. For example, here this Tim. If we have this and run our code again, you can see we got our Tom still inside of our list, but our Tim has been added into end of our list. And of course, you can do several things with this. For example, let's say after this Tim, we want to add this Will here. If we run again, you can see we got both of them right here. But in some other cases, you want to insert one item to some specific index and place. For example, you want to add this Tim before of this Tom and into index 1. And for that, you should use this insert method. But in our insert method, we're going to have 2 parameters. Second one is going to be the new value that we want to add into our list. But the first one that we have is going to be the number of the index that we want to put this item in there. So if we want it to be here before of Tom and after Jack, we should put the index of 1. And now if we put this 1 right here and run again, you can see this time we got this Tim right here and then this Tom right here. But as well as adding the items, in some other cases, we need to remove some items from our list. And the way that we're going to do that is by having our remove method right here. So we got our remove method and then simply we put what we want to remove from our list. If we want to remove Jack, for example, here we put Jack. But in this case, we want to remove this Tom. So we pass this string and this Tom. Pay attention, this must be as same as what the item that you have inside of your list. And now this time if we run, you can see we only got Jack and John and we don't have this Tom anymore. But if you want to use index instead of that, for example, if you use this remove 1 and run your code again, you can see you got some error because this is going to compare the value you put inside of these parentheses to each one of these items and find that and remove that. And this remove method is not working by index. The other thing that we want to use to remove one item from our list, which is going to remove the last item of our list for us, is our pop method. And what this does is going to remove the last thing and last item from your list. So if we have this pop right here and run again, you can see we got Jack and Tom, and we don't have that John anymore. But the cool thing about this pop is this one returns the last value for you. So if you have this name, for example, right here, and after having your list, you simply print this name into your output. If you run, you can see it grabbed the John from our list right here, put that in this variable of name, and then we printed this right here. So this pop method is great when you want to remove and use the value at the same time from your list. After these items, we got another popular and cool thing and cool method of clear in Python, which empties the list for us. What I mean is, let's say here we select our list 2 again, and then we use this clear method right here, which receives no parameter and runs just like this. Now, if we run our code, you can see this time our list is empty. So our clear method is going to pop and remove all of these items, but it still holds this list too. And we can, of course, append some other thing to this. For example, let's say here we got this list 2 and we want to append this number 1 to it, then this number 2 to it. And again, we want to print after these appendings. If we run this, you can see at the first it's empty because here we got cleared our list and then printed our empty list. But then we have append 1 and append 2, and we added these two items into our list, and then we printed that and we got both of them in our list after this appending. But let's comment these items for a second and run again. You can see here we got our empty list. We got another thing which is very good, but you should be very careful when using this, and it's del command, which deletes the list entirely. So if you use this del and then this list 2, for example, you can see we got this and then printing of our list 2. And if we run, you can see we got error of list 2 is not defined. Because when you're using this del, it's going to remove your list entirely. So after this line runs, it basically removes this line and that list for you. And difference between of del and clear is this. You can use clear, as you saw earlier, to make your list empty and then append and add some other to that and use again. But in del, if you use the same syntax but del instead of clear, if you run, it's not going to be run and not going to work. After these items, we got some useful list methods that we want to cover together. Python gives you many useful methods for work with lists, which here is some of them. And for this, let's reshape our list 1 numbers from 5 to 1, but in some random orders. The first thing that we want to have is our sort method. And the way that we want to use this is simply having our list or array name right here, which is this list 1, and then we have this dot sort at the end. And if we run this, it's going to sort this list for us. And if we want to see that, we're simply going to print our list 1. Now, if we run this, you can see we got our sorted list right here. Here we got 5, 2, 3, 1, 4, but here it's sorted from 1 to 5. But in some cases, you want to sort from biggest to the lowest. So you want the 5 to be at first and 1 be at the last. And to that, what you need to do is having your reverse method. And the way that it's going to work is having your list name again, then this reverse method. And after having this, if you run again, you can see this time it flips. But pay attention, it's not going to be only with sort, and you can use your array and list and reverse itself too. And it simply reorders it from last to first. So if we have this reverse right here, we should get the result of 4 at first coming into 1, 3, 2, and 5. As you can see right here in our output. The other method that we're going to talk about is our len, which for that we don't need that kind of doing at the first and printing after that. Actually, we want to do that inside of our print method. And the way that we're going to use it is simply having this len and then have the name of our list inside of the parentheses. And by having this is going to grab and returns the length of our array and list for us. So if we run, you can see we got the value of 5, which this means we got 5 items inside of our list. As you can see, we got 5 items right here. The other method which is working in this syntax is going to be max method, which this one is going to return the maximum value of these items for us. Because here 5 is the largest number, it's going to return number 5 for us. Pay attention, if we have this, for example, number 50, because this is the largest, again, it's going to give us this 50 because that's the maximum between of these numbers. And of course, as same as this maximum, we got this minimum. And that is by having this min or min method. And if we run, you can see this time we got the minimum number right here. And the next cool thing that we have here is our sum method, which this sum, it's going to grab all of these values and adds these numbers together and returns the total number for us. So if we run this, you can see we got the 15, which is the result of adding all of these numbers together. And the last thing that we want to talk about list is checking if some value is inside of our list or not, which, as you remember from the string and how we checked some part of the word is inside of the string or not, it's going to be similar to that. For example, let's say we want to check if the item of Tim is inside of our list too. So we got our Tim, and then we got this in, and then name of our list, which is our list too. So the value must go right here, then we got the in right here, and the name of our list here. And this time, if we run, it's going to give us true or false value. So this is going to return Boolean values based of if this is inside of the list or not. And if we got this Tom, because we got Tom right here, if we run again, you can see we got this true value. And now, after having these items, let's use all of the things that we learned together in some real-world example. And for that, we're going to have this simple shopping list right here, which is going to be empty list at the first. Then we're going to have some infinite loop of while true, which this one is going to run until we stop the program. And then we're going to have this item, and here we use our input. So we want our user to be able to input the new item that he or she wants to add to the list. So here we got this add an item to your list. But we're going to have another parentheses right here to tell them how to finish and exit the program. So we're going to say or type done to finish. And now by having this, we're going to have input, and our program is going to ask our input each time for us, and doesn't matter what we put, it's going to ask us another time. So if we come here into our terminal, pay attention, because we're using input, we're not running with this extension, and we're using this terminal. And if we run our program right here, it's going to ask us. If we put anything, it's still going to ask us. But we don't want this. What we need to have is if our item equals to this simple done, we want to break out of our loop. So if we run this again, if we have some random things, we got all of them. But if we put this done, it's going to stop the program for us. Then if it's not done, So we come out of our if loop and we come into our while loops scope, and we want to add this item into our shopping list. And the way that we're going to do this is having our shopping list right here and then using this append method. And then we have this item right here. And we can have this print of our shopping list each time after user entered new value. So if we run our program again, let's clear our console first and then run again. So at first, let's say we want egg. You can see we got this egg item printed into our console. Then let's say we want milk, we add that one here too. Let's say we want some orange, here we can have that item too. And if we put this done, it's going to stop the program for us. But we can have some other thing and not showing the list each time and only showing the list when the user done typing and importing new values. And the way that we're going to do that is simply moving this print out of our while. So in while part and while loop, we're adding into our list, and when it's out of this, it's going to print the list for us. So if we check that again, here we got our egg, then our milk, and then our apple, for example. And now we done, and this is our list. And of course, we can show our list better in good syntax and prettier by using our for loop. So here we're going to have simply our print right here, which tells here is your list. And then we got this for item in shopping list to these items. And what I mean from this is come into our shopping list, see how many item is inside of this. And basically this item is variable, which each loop and each time it's going to be one of the items inside of this shopping list one. So when it runs at the first, this item is going to hold the value at index 0. The next time it's going to hold the value at index 1. The next time value at index 2 and going on. But this is dynamic and it's going to calculate that for you. And here we're going to have simply this print. We're going to use simple concatenation. So we're going to have this hyphen right here, some space, and then we add that with our item. And now if we clear our console and run again, let's add our egg and our milk here. And let's add another apple here as same as some orange. And now if we type this done to get out of our loop, you can see here we got our list, which is egg, milk, apple, and orange. And this is a great example of lists, loops, and input working together. And now you know how to create, access, modify, and loop through lists. In this episode and this part, we're exploring 3 super important data types: tuples, sets, and dictionaries. By the end of this video, you'll know how to use each one, when to use them, and what makes them different from lists. The first thing that we have is tuples, which a tuple is just like a list, but it's immutable, meaning it cannot be changed after it's created. And for creating that, our syntax is like this. First, of course, we need to have name for our tuple, which in this case, I'm going to use this tuple1 right here. Then we equal that with these parentheses. And inside of this, we can define the things that we want. For example, let's say here we want to have simple numbers from 1 to 4. And by having this, if we come one line below and print our tuple and run our code, you can see we got our tuple right here. But if you remember from the last part that we got our methods like pop, insert, and other things, if we wanted to write them on our tuple, so we got our tuple1 and then we want to pop. If we run, you can see we got error that tuple object has no attribute of pop. But let's say we want to replace one of these items. If we want to replace the item at index 1, for example, and we equal that with number 5, if we run, you can see that we got this tuple object does not support item assignment, which meaning we cannot change this after we created this. But you can access the items just as we did in the lists. in previous parts. So we can have this square brackets, and here, for example, let's print item at index 2. If we run, you can see we got this item printed into our output. And as same as list, it doesn't matter what you want to have here. You can have both of the strings and numbers at the same time in one tuple. And if we run, you can see still we got these items. But one other thing about tuple is we cannot have single item like this. If we have our tuple and we want to store only one item inside of this, let's say actually we want to have this string of word Python here. If we run this, you can see we got this Python. But this is not tuple and the way that we want. And the way that we can create tuples with only one element inside of this is going to be our item, then our comma. And if we run this time, you can see this time we got our item as tuple. But why you should use tuples? Well, they're faster than lists and they're safe when you want to prevent data from being changed. For example, maybe you want to have some static data that you don't want to change them in any situations. It's better to put them in tuple instead of the list. But now let's come and talk about our next type, which are sets. Well, set is an unordered collection of unique items, which means no duplications is allowed inside of sets. And for that, again, we're going to create set here, and the syntax is going to be name of our sets right here. For example, in this case, I'm putting set1 again, and then we're going to have these curly braces right here. And inside of this, we're going to put our items. For example, let's say we want to have items from number 1 to number 4. And if we come here and again print our set1 right here into our output, if we run this, you can see we got our items right here. But if we have one of these items twice in our list, for example this number 3, if we come here and run again, you can see we don't have this last 3 right here, because it's going to automatically remove the duplication and only saves one of the values that we have right here. So it doesn't matter if we have another 4, another 2, it's going to remove all of the duplications and only hold one from each item. But if we have another 5 right here, if we run again, you can see we still got our 5, but none of other duplications. But here in our set, we got some other operations that it's good to know. Well, here, let's say we got another set2 right here, which this one is numbers from 4 to 6. And our first one is numbers from 1 to 4. And here, if we want to mix these two items together, what we need to do is having our set1 or set2, doesn't matter, then we're going to have this union method, and then inside of these parentheses, we're going to put our set2 right here. And now this time, if we run, you can see we got both of these items joined together, but we only saved one of the 4s because it's going to be duplicated when we add these items together. And then the other one that we have, which is a very good method, is our intersection, which this one finds what is common and available in both of our sets. For example, in this case, we got our number 4 to be both in the set1 and set2. So we're going to have this intersection, and if we run this, you can see we got our number 4 right here. Of course, if we have, for example, number 3 here, if we run again, you can see we got both of them right here. And another operation that we have is our difference, which this one, as it shows from its names, it's going to tell us which values are different between of these items and sets. And if we run, you can see we got this 1 and 2. But if you pay attention, it's not going to print this 5 and 6 because we want set 1's difference from set 2. So it's going to grab and return us only the things that are in set 1 and not in set 2. But if we want to have items which are in set 2 and not in set 1, we need to change the place of these items. So by having this syntax, if we run, you can see we got this 5 and 6 this time. But unlike the tuples, which we cannot change these items after we created them, in sets we can add and remove items here. So if we want to add number 7 to our set 1, what we can do is have our set1 and then we have this dot add and have number 7 right here. And now if we print simply our set1 here, if we run, you can see we got our number 7 right here. And as same as this one, we have our dot remove, which if we have this set1 again, then we have this remove method. And here, let's remove number 2. If we run this, you can see this time we don't have our number 2 inside of our set. Now, the last thing that we want to talk about in this part is our dictionaries, which these stores data in key value pairs. And it's like a mini database. And the syntax and the way that we're going to create this is having the name for our dictionary. For example, in this case, I'm going to create the dictionary with the name of person. Then we equal that again with our curly braces. Pay attention, in our sets, we got our curly braces and then we put items like this and comma between of them to create sets. But in dictionaries, unlike this, we're going to have this string as our key, for example, the name, and then this double column, and then the value for this name. For example, let's say we got this Jack here. Then we put comma right here and come and put the next key that we want to have. For example, let's say we want the age of this person. So again, we got these columns and we put the age, for example, 30. And then again, we can have and add other things that we want. Pay attention, in dictionaries, we store all of these data which are related to this person, for example, this Jack, in one dictionary. And this basically holds several values. Let's say we want to store the name for person 1. We're going to have this person 1 name variable, then it's going to be this Jack. Then let's say we want to have another person 1 age. We equal that with its age, which is 30. And let's say we have several other things. This can be, for example, city, which let's say he's in New York, and going on. This is a complex way and not good way to store all of the data related to one person and one subject. Instead of this, we can have our dictionary about our person 1, and here we can have this person 1 and have all of these data. And for example, let's add our city here too. So we got our city to be New York. And then after we created these items, we can access anything and any item inside of this. Pay attention, here in our dictionary, we're going to refer to this one as our key and this one as our value. And basically, we got person 1's name to be Jack, person 1's age to be 30, and person 1's city to be New York. Then for accessing only one of the value, what we can have is, let's say we have our simple print here, then we target our dictionary at first. So we got our person 1. But unlike other things which we put index right here, like sets or tuples or lists, here we're going to put the key for the value that we want. For example, let's say we want the name. If we put the string of name right here, if we run, you can see we got this Jack printed into our output. Of course, we can have our age. If we run, you can see that. And as well as that, we can have our city. And all of them are going to work very efficient. And if you want to print all of them together, you can have print this person 1. If you run, you got all of the things that you put right here. But how we can add and update our items inside of person 1 using code? Well, the way that we're going to do that is having again our person 1 right here. Then we're going to have our square brackets and we're going to put the key right here. For example, let's say we want to change person 1's age. So we put this age right here and then we equal that with, let's say, number 20. Now, if we run again, you can see this time our age is 20 and not 30. And we updated it right here. But let's say we want to add another field and key value thing into our dictionary. The way that we can do that is having our person 1 again. And here we put the new key that we want. For example, let's say here we want to save the job for our person. And then we equal that with the value that we want. For example, let's say we want to say he is programmer. And now if we run our code again, you can see this time we got another field of job, which is this programmer. And if we want to remove one of these items entirely, for example, let's say we don't want to have the city for our person, what we can do is using our del. And this del simply is going to delete the field and key value pair that we want to remove. And here we're going to have our person 1 again, and here we want to remove this city. And now if we run, you can see this time we don't have that city anymore. Here in our dictionaries, we got some methods that are very useful and we can use. Which the first one is the method of keys. Which what this does is going to grab all of the keys and return them for us. So let's say here we got the key and then the value. And if we run this keys, you can see it grabbed all of the keys for us. Name, age and city. And printed all of them for us. And as same as this keys, we got this values. Which this one is going to grab all of the values and return them for us. But another one which we can use, which is going to grab the items and each pair and return that for us, is our items method. And if we run this, you can see this grab the key here, which is the name, and the value, which is this jack. And we can use this in several functions, and it's very useful in using our dictionaries. And dictionaries are ideal when you need to associate labels or identifiers with values, like names, IDs, prices, settings, and more. Now you know how to use tuples for fixed data, sets for unique items, and dictionaries for key value storage. And if we want to have recap for all of the things that we learned together, well, here we're going to have our dictionary, which is like this. We're going to have our sets, which is going to be like this. And the first one was the tuple, which is going to be in parentheses and like this. And if we want to have some note about these items, well, the tuple can't be changed after created. Then we got the set, which has this unique items and no duplications. And then we got our dictionaries, which these are the key value pair like mini database in program. And this was the recap for this and what we learned in this part. What is function? Function is a block of code that runs when you call it. You define it once and you can use it how many times as you want. Think of functions like mini programs inside of your program. Now let's create a simple function. For creating function, first thing that we want to have is the keyword. Then we're going to have the name for our function. For example, in this case, I want to make the name of my function to this talk. And then we're going to have these parentheses and these columns. And then we're going to come into this block. We come into the block in Python by using space. So we got this space here, and then we can put any code that we want right here. For example, let's say here we're going to have the simple print, and here we're going to have the simple hello world. Now, by simply having these two lines, we defined and created function. But if we run our code, you can see nothing is appear and going to be in our code. Because when we want to use function, we should call it. And what I mean from the calling is come here in our file scope and outside of our function and simply have the name of our function and then these parentheses in front of that. And when we put that, this means come to the function of talk, which we have right here, and run the code inside of this function. And now this time, if we run, you can see we got this printing of hello world. But because this is function, we can run this as many times as we want. And if we run, you can see we got all of those printings and same code repeating by each time of calling the function. And you can have several things inside of your function. For example, let's say we want to have another print here. This time we want to have this divider, for example. And again, if we run, you can see we got these dividers printing each time when we calling our function. And if we call it once, we got our hello world and our divider just like we put right here. And pay attention, if you don't put these parentheses and run, you're not going to see anything right here. And only by having these parentheses, you're going to be able to run the code inside of the function. And actually, if you think of the print statement that we got is another function too. So when we got this print and these parentheses, it's going to run the function of print for us. But what are the things that we put right here inside of our print? Well, those are what we call parameters and arguments. And that's basically for having dynamic functions. For example, let's say here, instead of having this hello world, we want to print hello to the user with his or her name. So here, we're going to define some parameter, and we use that by only having the name right here. And we can say this is basically a variable for only inside of this function. And here, instead of having the world, we're going to use simple f string right here, and here we're going to have this name in our string. And this time when we calling our function, here we got our tag function, and here we can put some arguments. For example, let's say we want to say hello to user with the name of Ted. Now if we run this, you can see we got this hello Ted printing into our output. And the way that this works, we're calling function, and our function of talk has this variable and parameter. And when we putting something right here, we mean put the value of this variable and parameter, this Ted, which we pass right here. And then when our talk function runs, it's going to come to this line, and when it comes here into the name, the value of this and this time of running is 10. But if we want to use this another time, for example, let's say this time, we're going to have this to be Tom. If we run this, it's another time of running, and this time the name is going to be Tom. And of course, we can have as many times as we want and run our code several times. And we can have several parameters here too. For example, let's say we got this name and then we got this age. This time we want to print another statement of this name and then is age years old. And now when we have these items, if we run, you can see we got error of missing one required argument of age. And to fix this, we should add the age for these items. For example, let's say 20 for Ted, 30 for Tom, and 25 for Jack. And this time if we run, you can see we got Jack is 25, Tom is 30, and Ted is 20 years old. But in some cases, we want to have some default parameters. For example, let's say we get rid of these age things that we put here, and we only have our name. But we want to be able to run this talk function like this and print hello user into our output. What we can do is having this equal right here and then putting this user. And this means when we run talk with no parameters right here, passing into the function, and the meaning of passing to the function is putting something and some value inside of these parentheses. And when we don't pass anything, it's going to make the value of this name to this user. But if we pass something into function, it's going to come and replace this user. And now this time if we run, you can see we got hello Ted, hello Tom, hello Jack, but when we come to this time of running, which we have not passed anything into our function, it's going to print hello user right here. And if you have several parameters right here, for example, let's say we got another age, after this we got another job, for example here, and we want to print all of those. So let's say we want to have simply the name here, then we want to print simply the age and job next to each other. But you can see here we got this error right here, and this is because of our keyword arguments, which when we want to have this default value, we should have this at the end of our code and not at the first. So we should have these one which doesn't have any default values at first and the one with the default value at the last. But here in our calling function, we should pass the items by this order. So we should pass 30 for the age, for example, this programmer for the job, for example, and then the name, which was this Ted. And let's remove these two items for a moment, as well as this one. And now this time if we run, you can see we got this hello Ted and its age and job right here. But if we want to put these in some random orders, we can do that in different way. If we put the simple Ted right here and do just like this, if we run, you can see it's going to mess up because it's going to grab this Ted as age, it's going to grab the 30 as job and programmer as name. The way that we're going to fix this is here we put the name of our parameter right here and equal that with this value. What I mean is, let's say here we're going to have this name to be Ted, then the age to be 30, and job to be this programmer. And this time if we run, you can see it fixed again, and we can pass by any order that we want if we obey to this rule of having this type of passing arguments into our function. Now let's get rid of all of the things that we have and let's clear our output too. And let's create another function for simply adding two numbers. Here we're going to have this def, then we're going to have the name of our function, which is this add nums, for example here, and our parentheses. And we're going to have this columns, and we can come here and do anything that we want. For example, in this case, I want to receive two variables and two parameters of a and b. And then inside of my function, I want to have this result, and I equal that with this a plus b. And now if we come here out of our function and run our add nums function right here, and let's pass this 2 and this 3. And if we run our code, you can see we got nothing right here. Of course, we can have this print of our result in our function, and if we run this time, you can see we got this printing. But in some cases, we're not going to print in all of the scenarios. In some cases, we want to receive this result and save that, for example, in another variable of total, and maybe we want to print this total times 2. And the way that we want this to return some value to right here is by having our return keyword right here. And this time we can have this result right here, and this simply means when we run this add nums, it's going to grab this 2 and 3, add those together, put the number 5 in this result and return that for us. And what I mean from returning is, think of that instead of having this, it's going to be this 5. So our total is going to be 5, and the total times 2 equals the 10. And if we run, you can see the same thing happens here, and we got this 10 right here as our result. And of course, we can have this in another way of this print, and then having our function run inside of our print method. And here it's going to be the number 5 for us. And if we run, you can see we got this number 5 right here. Now you know how to create functions, pass data in, and get data out. If you use functions, it will make your code cleaner and more powerful. Where a variable can be accessed, how much is its lifetime, and how long that variable exists in memory. In this part, we're going to answer these questions. First concept that we're going to cover is scope. And scope is simply the part in your program where a variable is recognized and accessible. Think of this as your program is created by several rooms next to each other. And for example, 4 room creates one program. And for example, if you have some ball in one of your rooms, other rooms can't see and use that ball. And in this scenario, we tell that the ball is in the scope of the room. And in our programs, our scope can be local, enclosing, global, and built-ins. But what are these and how we can use these items? Well, let's start first with our global scope, which global scope is where all of the other things and all things that we have can be accessed to variables in global scope. For example, let's say we got the simple x variable which holds number 5 inside of it. And in our programs, our rooms are simply our functions. For example, here we're going to have this function 1 and has something right here. Then let's say we're going to have 2 another functions with the names of f3 and f2. And as I told you, these are basically our rooms. And if we want to create a global variable, we can create that in our file. When we are outside of all of our functions and in our file, this means we are in our file scope, and this is as same as our global scope. Let's have example of how this item works. Well, here let's say we got this x which has this value of 5 inside of it. And in all of our functions, what we want to do is simply print this x into our output. But because we want to see which one is printing, here we're going to use f-string. We got this, then our x right here, and then this from function. Then here we're going to put the number of the function and close our string. And here we're going to have number 1 at the first, Here is our 2 and here is number 3. Now if we come outside of our functions and into our file and run all of our functions, so we got f1, f2 and f3. And if we run our program, you can see we got this result that 5 from function 1, 5 from function 2 and 5 from function 3. And actually we can move this output here into the side, so we can see this output right here as well as our code at the same time. And now let's get back into our code. Here you saw that x is a global and can be accessed anywhere. But let's say we want another variable right here with this y. And here we equal this with number 7. And let's say here in our printing, we want to print y instead of that x. And now if we run, you can see we got some errors right here. Which if we come down, you can see that we got this name error of y is not defined. But you can see that we got y right here. And that's why our 7 from function 1 worked, but none of others worked. So, as I told you, think this function as one room. Here we got this variable, so the things and lines of codes that are inside of this f1 function can access this variable of y and use it. But in f2 function, because this is in another room, it doesn't know that we got this variable of y right here. And as well as that, our function 3 can't use this item too. And just as same as we got this y right here, we can have another's here too. For example, let's say we got this a to be number 3. Here we want to print a, and in our function 3 we want to print a2. If we run this, you can see we got this 7 from function 1, 3 from function 2, because this a can be accessed this a. But again, we got this name error of a is not defined in our f3. But how we can access that y variable in all of our functions? You know that we can define it right here in our global scope, but let's say we don't want to do that and we want to create that in this f1. So the way that we can do this is by simply having this global keyword before of our variable. But you can see that here we got this error, and if we run like this, again it's not going to be run. And that's because here we first need to make this y global, then assign some value to that variable. For example, in this case, we created and made our y variable global, then we assigned number 7 to that. And now this time, if we run our code, you can see all of our functions can access this variable of y. Here you can see we got 7 from function 1, from function 2, and function 3. But what happened if we have some function inside of another function? Well, let's remove these functions from here and only got our f1 function. And let's make our y variable local in f1 and not global. And here let's say we got another function, and here we got this inner f1. And here inside of f1, we simply want to print this y. And now we're going to call our inner f1 inside of our f1 function. So here we're going to have this inner f1 right here. Pay attention. Here we created our inner f1 function in our f1 function, and here we're going to call it in our f1. So here it created, and here we're calling it. And at the scope of our program, we're going to call our f1 function right here. Now, if we run our program, you can see we got the 7 from function 1 and this 7. Actually, we can have this kind of printing right here too. So let's fix this. And here, instead of function 1, we're going to say from inner function. Now, if we run again, you can see we got the 7 from function 1 and 7 from inner function. But what if we have another y inside of our f1 function right here? For example, let's say inside of this we want to have this string, which is this changed in inner function. And let's say we want to print our y again at our f1 function right here. So here we're going to have this y. Now, if we have this kind of program, if we check that, here we created our y variable with the value of 7. Here we're printing that and saying that it's from function 1. Then we have our second and inner f1 function here, and we got this y here again and has this value of changed in inner function. Then we're going to print this y again in our inner f1, which tells this y from inner function, and then we printing this y in our f1. And actually, let's print that at the last after calling our function. And now if we run this, you can see here we got the 7 from function 1 right here, which is this one that printed the 7 here and from function 1. Then we got from inner function. So here it's going to grab this y and print this, but if we check here, you can see when we printing this y, it's again the 7 and not this second value. And actually this y is going to see and use this one and not this one. But how we can have this y refer to this one instead of this? So we got this y, we want that one to be changed here and then use that here too. For example, let's say instead of this string, let's say we want this number 10. So for that, what we need to do is simply as same as we did with global. Here we got this non-local. And then we pass the name of our variable. Now this time, if we run our program, you can see we got the 7 from function 1, 10 from inner function, and then when we want to print this y, because here we not created another local variable in our inner f1 function and changed this variable's value here, it's going to grab the second value and the last value that's assigned to this variable. And basically here, non-local allows the inner function to change the variable from its enclosing scope. And what I mean from enclosing scope is the scope that this function has, which is this f1's scope. Now we learned how these systems work, but how long our variable is available for us, how much time it takes to be inside of a memory, and we can use that. Well, for that, let's remove all of these items as well as this x at the top, and we only have this y as our variable right here. And here we're going to simply print this y in our f string, which here we put this y and then from f1. You know, if we run this, we got the 7 from f1. But what is happened if we do the same thing right here in our global scope, but instead of this f1, we say from 5. If we run this, you can see again we got this name error, which tells us the name y is not defined. And basically here, the thing that does this is our lifetime. The lifetime of a variable is how long it stays in memory, which global variable like this x that we got earlier in our code lives as long as the program runs, but local variables like this one is created when the function starts and destroys when the function ends. So we can use this local from here that we defined it until where that we are inside of this f1 function. And after we moved outside of the f1, if we don't use the global keyword, it's going to destroy this variable automatically. But what are our whole scopes? Well, we know that we got our file scope that contains our local scopes, and again this locals can contain other locals. But this file scope itself is going to be in this built-in scope. And basically this built-in scope is above of our file. Think of our program as some buildings. We got this built-in scope as our building. Then we got this file scope as our floor. And then we got this locals to be rooms inside of that floor. And if we got something right here in our building, it can be accessed from all of the things, the apartment itself, floor, and the rooms. If we got something in our floor, only the things inside of that floor and the rooms in that floor can be accessed. And if we have something in one of the rooms of the apartment, it's going to be accessed only from that room and rooms and places inside of that. But here Python has this built-in scope which includes things like print, len, or range, which you should never override these items and these names accidentally. And if we want an example of the thing that I'm saying, think of that we got this empty file right here and we got this simple variable of a to be this string of Python, for example. And of course, you know that we got this print, and here we can have this len method. And here, if we pass this a right here, if we run our code, it's going to return us the length of our string. But let's say in some cases we accidentally overwrite this len and assign this with another value. For example, let's say this number 5. In this case, if we run our code again, you can see we got this error and it says int object is not callable, which means when we created this len variable with the name of 5, when we want to use that built-in method of len, it's not going to see that and it's going to refer to this one that we got right here. And of course, it doesn't have any meaning to have this len equal 5 and parentheses and this variable of a. And as same as this, if we have, for example, this print here to be this 5, if we want to print our a here, if we run, you can see nothing is going to be happen again. So always be careful not to shadow Python's built-in functions. Now, for the recap, we learned about the LEGB rule, local, enclosing, global, and built-ins, and how global and non-local keywords help us manage variables. Learning these concepts will save you from confusing errors as your programs grow bigger. How to transform, filter, and combine data effortlessly in Python. Stick around till the end of this video because I'll show you exactly how to do that using the powerful built-in functions map, filter, and zip. First, for using our functions, we need some simple list, which here I'm going to have this number list, which is numbers from 1 to number 5. And of course, here we're going to have simple print of our list. And if we run our code, you can see we got our list printed into our output. But now let's say we want to make all of these numbers double. So we want to have another result variable right here, which we want this to hold double the values of this, which are going to be 2, 4, 6, 8, and 10. But we want to do this automatically with our built-in functions. And to do that, what we need to do, instead of having this list right here, we're going to use map function, which this is going to receive 2 items and arguments from us. First one is being the function and the thing that we want to do on the list, which for now, I'm going to simply have this function name right here. And the second one is going to be our list name. And we need to create this function to do the work for us. Because if we run this, you can see we got this error because we don't have this function defined in our code. So here we're going to create this function of x2, and here we're going to receive this parameter of x, and we're going to return this x times 2, which what this does is basically is going to grab this x, make it double, and return that. And if we want to check that, let's comment these items out for a moment. And here, let's say we want to have this a variable, which is this number 5, and then we're going to print this x2 function and this a. And if we run this, you can see we got the value of 10 right here. And we're going to do the same thing with all of these items. But how we should do that for each of these items? Well, the map function is going to do that for us automatically. So here, instead of this function, we're going to have the simple x2 right here. And this is going to come to the list of number and pass these items inside of these numbers to this function that we got right here and then return those for us. So if we have this print of results right here, if we run this, you can see we got this map object because this is going to create an object with those values. And because we want to see them, what we need to do is having this list method here and wrap our result inside of this. Or we can simply have our result here when we're creating this. So we got this list and then this map, and this does the same thing for us too. And now if we run, you can see we got this new list, which has the double values of our original list right here. And another example that we can have is with our list of strings. So let's say here we got this words list right here, which here we got this Python, then maybe this apple, and let's have another banana right here. And now we want to uppercase all of these words. Well, for that, first we need our function. And the way that we're going to do that is simply using our upper method we got in Python. So if we got this print of this word 1, if we run, you can see it's going to be this apple. But if we want to make this uppercase, what we can do is use this str.upper, which this is built-in string method that we got in Python. And this time, if we run our code, you can see we got our result in uppercase. So if we want to use our map method here, we're going to have this upper words, and we equal that. Again, we're going to have this list because we want to create the list at the end of this returning of the map, as same as the thing that we done right here. And then here we're going to have this map method, and then we're going to pass first our function and then our list. And here our function is predefined and we don't need to define that and create that here. So we're going to have this str.upper right here, and then the name of our list, which is this word. Actually, let's make this words just like this. And now after we done this, what we need to do, we simply want to print this upper words into our output. And now if we run, you can see we got this result of Python, apple, and banana in the uppercase. So basically, the map is about transformation of one thing into another, and it works with any iterables like lists, tuples, and etc. But let's come into our first example, and here let's say we want to grab only the even numbers and not odd ones. How we can search in our list? Well, we're going to do that with our filter method. And the way that we're going to do that is again by having another function, which this time our function is going to have this name of isEven. And it's going to grab some number right here and return us the Boolean value of if the number that we got is even or not. And we check that by this remaining operator of 2, and we say grab the x, divide it by 2, and if the remaining of this division is equal to 0, then return us 1, which this does the same thing for us. And else it's going to return us the false value. And then here we can check that by simply having this isEven method right here, and then pass that some number, for example this 5. If we check, you can see we got the false, and if we pass this number 4 here, if we run again, you can see we got this true value right here. So let's use this in our numbers and use our filter method to search in our numbers. So again, we're going to have this result. We equal that with our list method because as same as the map function, this is going to grab those items for us, but we want to put them in some lists. And then here we're going to have this filter function. And again, here it's going to grab 2 items from us. First one is being the function of our logic, which in this case is going to be this isEven. And the next one is going to be our original list, which is this number. And then here we can print this result into our console. And now if we run our code, you can see we only grab the even numbers between of these numbers, which is this number 2 and number 4. And of course, we can make this the opposite to find odd numbers for us. So this is going to be odd, as same as this one. And here we should change our logic, as you can see right here. So the remaining must be equal to the 1. And now this time if we run, you can see it grabs the odd numbers for us. Now let's come again into our second example, but this time let's create another list here, which is this names, and we equal that with this list of Tom, Ted, for example, Alice, and another one of this Bob. Now here, instead of having these items, let's say we want to grab only the names which has 3 characters. So to do that, here we're going to have our function, of course, which you will learn in the next part that we have Lambda functions that we can use them without creating this kind of functions. But for now, we're going to stick to this way and code like this. So the name is going to be is3chars. And again, it's going to grab the name and we want to return if the name's length, so we got this function and method of len here, is equal to 3. And then here we're going to have our result list here. We equal that with this list again. And here we're going to have this filter, and here we should have 2 parameters. First one is our function of is3chars, then we're going to pass the names. And now if we come one line below and print our result into our output, so here is going to be our result, and here if we run, you can see we got only the items and names which has 3 characters. which are this Tom, Ted, and Bob, which you can see right here. And basically, filter is about selection and searching inside of our list. And it returns only the elements and items where the condition is true. But let's say in some scenarios, we got these names right here, and then we got scores for these people. So we got some random numbers here, just like this. And let me fix the name of this scores. And now what we want to do is pair these two items together to see a list that Tom has 85, Ted has 95, Alice got 60, and Bob got 80. And for doing that, we're going to use our zip function. And zip allows you to combine multiple sequences element by element. What I mean is, let's say we're going to have our results right here. Again, we got this list, and inside of this, we're going to use our zip function. But unlike the other and previous two functions, this time we don't want any function to put here. What we need to do is only passing the name of our lists. So the first one is going to be this names, and the next one is going to be this scores. And now by having this, if we have this print and print our result into our output, if we clear our output and run again, you can see we got this type of pair of Tom 85, Ted 95, Alice 60, and Bob 80. Pay attention, this works with the order and gives the Tom this number of 85, Ted this one, Alice this one, and Bob this one. So in this method of using, the order is so important. But what happened if we got another item right here? For example, let's say we got another name of Jack right here, but we don't have any number and score for him. If we run this, you can see we only paired the items that we got a score to them and not to Jack because we don't have any number and score for Jack. And if we got the opposite one, for example, let's say we got this 97 for the Jack and we got another 78, which is some extra number and score, and we don't have any person assigned this number to. If we clean our output and run again, you can see this time again we don't have and we don't do anything with this number of 78. So let's remove this one, and we got right numbers right here, and you can use this type of spacing to be able to see each person's details below them. And let's say we want to have another list of age right here, which this one is holding the age for these persons. And let's fill this list up. And now let's say after we got this Tom and 85 score, we want to add the age to this item too. And with this zip function, it's very easy. What we need to do is only having this separator of comma right here, and then add the name of the list that we want to add here. And now this time, if we run, you can see we got the Tom's name 85 score and the age, which is 28, as well as other items that you can see right here, like Jack 97 score, 32 years old, and all of others. But here let's remove this age, and here let's say we got this result right here, but we don't have these items. How we can separate these items into names and scores? Well, let's first print this into our output. So this is our first one. Then for separating these items, we're going to pass two names for two lists that we're going to get. First one is going to be the names, and second one is going to be the scores. So we're going to have this names right here, then separate that with comma, and then the scores. And we equal that again with zip function. But pay attention here, instead of having that name of the list and combining, if you put this star at first and then name of your zipped list, it's going to come and take these items and separate these two from each other. Put this first one, which is name, in our names list, and this 85 in our scores list. So if we want to print those items, here we're going to have print of our names and then another one for the scores. Now let's comment this print of our zipped items and clean our output. If we run this, you can see we got two separate items of Tom, Ted, Alice, Bob, Jack, which is our names, and this numbers as our scores in our second one. So basically, we got our map function transform our items inside of our list to other things. We got our filter function to search and select what we want inside of our list, and we got our zip function combine two lists together or separate a zipped list in our program. In the next video, we'll talk about Lambda functions, short anonymous functions in Python, and once we combine lambdas with map and filter, you'll see how powerful and compact your code can become. Have you ever needed a quick one-time function without writing an entire block of code? Well, that's where Lambda functions in Python come in. They let you create small anonymous functions in just one line. In this video, you'll learn what Lambda functions are, when to use them, and how they can make your code shorter and cleaner. First thing about the Lambda functions that we're going to talk about is this, that they are anonymous functions. And what I mean from this is it doesn't need a name. So let's have some simple variable right here of x and equal that with the value of 5. And then let's say we want some simple function, which if you have not watched functions video, here is a card that you can click and go and watch that part. And here we're going to have this simple function. And for example, we want to name this x2. And here we're going to grab our number. And then inside of this, we simply want to return this number times 2. And of course here, if we have this simply print statement, and inside of this, we run our x2 function and give this x parameter to this. If we run, you can see we got this number 10, which is our result. But the way that we're using Lambda functions are a little bit different. We can use them here in our print instead of this. So we make this line's comments right here, and then here we come into our print statement, and here we're going to start writing our first Lambda function. And the syntax is like this. First, we're going to have this Lambda keyword, and then we're going to have our arguments right here, then our columns, and then the values that we want to return. So it's simply like this. These arguments are things right here in our default function, and the thing that we're returning is just this part right here. But pay attention, it doesn't need any creation, and you can use this here in your print statement. For example, here we pass this x, and on the return we want this x times 2. And now if we run, you can see we didn't got our result right here, because we should not use this lambda exactly in our print statement. I'm going to show you how to use that in different ways and built-in functions, but for now we can save that in some variable. For example, let's say we got this variable of func, and we equal this with this lambda right here. And pay attention, this x is different from this, and this as argument. So actually it's better to make this number instead of that x. And now here on our print, we simply have this func, and then we pass this x into our func. And now this time if we run, you can see we got our result of 10. And both of these types of functions, here is our default function and here is our lambda function. Both give us same result, but lambda is faster to write and very easier to maintain. But why we should use lambda functions? Well, these functions are great for small temporary operations where writing def would feel like overkill. But don't overuse these items. If this function is complex, it's better to write in a normal function instead of lambda. But this helps when passing function as arguments to other functions. And basically it keeps the code clean when the logic is very simple. And in most of the functions that you receive some arguments and just you have some return in the function and nothing else, and you return some equations from that arguments, lambda function is very better way to go. As you can see here, we got some basic simple math operation, or we can have some checking conditions. For example, is even. So instead of having that as regular function, we're going to have this lambda, and here we're going to have is even, and then what we need to do is grab this argument of number, and then we divide it by 2, and if our remaining is 0, it's going to be even. And if we check it here, if we clear our output and run again, you can see we got this false. But if we make this 5 number 4, for example, if we run again, you can see we got this value of true. Another very cool lambda functions usage are in string manipulations. For example, let's say we want to have some function to simply reverse our string for us. So here we're going to grab our string, which I name it this word, and then here instead of this math, we want that word that we got, but we use this syntax, and you know here we got this start end and step. And we don't want any start and end here, so we make those blank, and on the step we make this -1. And here instead of 4 we have the simply word of Python, and if we correct the name here, so we got this reverse. If we run, you can see we got this string reversed in our output. But as I told you, one of the best usage and actually the main reason that Lambda exists is for using it when we want to pass some function into some other function, which we covered in the last part, which you can watch from the card. And here, let's say we want to have simple map function. So here we're going to have the simple list1, which holds these values from 1 to 5. And then let's say we want to double these items. So we're going to have this double, and we equal that with this list, and inside of this we have this map, and here we're going to pass the function for this and then our list, which is our list1. But here in our function, the old way that we does this is having another function here. For example, we got this function of f1 right here. Then here we're going to grab some variables, for example this a, and we're going to return this a times 2. And if we correct this name for our function, and actually we need to print this, so here we print this double right here. If we run this, you can see we got our result. But if we want to use Lambda, what we need to do is simply here, instead of this f1, we're going to put this Lambda keyword, and then we say receive some arguments, then return that argument times 2. And now this time, if we clear our console and run again, you can see we got the same result, but with very much easier and cleaner code, and all of the things is packed in only one line. But another built-in function that we can work with this is our filter function. And for that, what we need to do is simply change this map to this filter. And here, instead of returning this value, we say, for example, we want to return only even values. So we use again this x, and we check the remaining of that from the division of 2. And if it's 0, it means it's even, and it's going to return that value and that item for us. And now this time again, if we run, you can see we got our result with very much cleaner code. And of course, we can have for odd numbers too, and here is our odd numbers. But let's say we want to have some custom sorting for our list. And instead of having this list of numbers, let's say we have list of names. And here is our list of names, and we want to sort them based on their length. So what we can do is having the simply result right here, and then we equal that with this sorted method, which here we need to pass first the name of our list. So here we're going to have this list1 here, of course, and then we're going to separate that by comma. Then we're going to have this key, and we equal that with our lambda function, which in our case here is our lambda keyword, and we want this lambda to grab each one of these items and names. So we have this name right here and return the length of that item or name. And for that we got our length function, of course, and here we can have this name right here. And after having this, if we simply come here and print our result into our output, if we run our code, you can see we got our items sorted based on their length. We have this Bob, which have 3 characters, so we got this one at first, Alice with 5 characters at second, as well as David, which has 5 characters, and then we got this Charlie, which got 7 characters at the last. But pay attention, you should not use lambda functions in situations like if your function has complex logic, because a normal def function is better for that. And avoid writing unreadable code just to make it shorter. Sometimes some large codes and block of codes are better to understand, but if we make those in lambda and make them only in one line, it's hard to read and hard to manage. And at the end, lambda functions in Python are a powerful tool when used the right way. They are perfect for short, quick operations, especially when combined with built-in functions like map, filter, and sort. Imagine you're working on a huge project with thousands of lines of code. It would be a nightmare to keep everything in a single file, and that's where our Python modules come in. In this video, we'll learn how to create our own modules, import built-in modules, and at the end you'll see how to organize your code like a professional developer. What is module? A module is simply a Python file that contains some part of your program's codes, like functions, classes, or variables, that you can reuse these items anywhere, anytime as you want. And actually, every Python file is a module, and it helps in code organization and reusability. And Python itself comes with hundreds of built-in modules. Now let's create some modules to see how we can work with them in our program. So, for creating modules, what you need to do is come to your main directory and here create another Python file. And for this example, I'm going to name my file this module.py. And pay attention, this name is actually both for files and your module. And here, let's say we got a bunch of functions. For example, at first, let's say we got the simple function of hello, which is going to simply print this hello world for us. And then let's have another function, and here we name that this age, and this is going to tell and print that user is 20 years old. You know that we can run this and we can call these functions, but this is the point of creating module, to have, for example, your functions in different file and come into your main.py and use that functions in this file. But how we can use those functions and this module? Well, here where our importing come to place, and we can have 4 types of different importings. The first one is going to import this module for us. So we're going to have the simple import keyword and then the name of our module, which in this case is module itself. And if we want to use any function inside of this module, what we need to do is use this name of the file and module that we have imported right here. Then we put this dot and the name of the function that we want to run. For example, this hello. Then we put our parentheses, and now if we run our code, you can see we got this hello world into our output. And of course, we can have another line of code, and here let's run our age function. And this time again, if we clear our console and run again, you can see we got this hello world and user is 20 years old. But another thing that we can have is when we importing this, give this some other name and use that here instead of this module. For example, let's say in our code here, when we want to use these modules, instead of typing the word of module, we want to use the fns as functions. And the way that we're going to do that is passing some name right here. And the syntax is after we imported module, we put this as keyword right here and the name that we want. For example, in this case, I want to be that fns, and pay attention, after we declared and give that module a name, we cannot use the file name of the module that we imported anymore. So we need to remove this and use fns here too. And now if we clear our console and run again, you can see again we got the same result coming into our output. But let's say you want to use these items, but you don't want to have this fns dot or module dot each time, and you want to use them like this, as same as like that, you got these functions in this file and not another file. And for that, what you need to do is having this from keyword at first, then the name of your module, which ours is module here, and then here we put this import, and if we put this star, it means import all of the things that are inside of this file into this file. And by having this, we can run these files like this. And if we check that, you can see if we run, again, we got those results coming here into our output. But pay attention, this is not recommended because you don't want to import all of the codes are in another file to this file. And for example, maybe you only want to use this hello function and not that age. And for that, what you can do is instead of this star, put the name of the function that you want to use. For example, in this case, this is the hello function that we want to use. And this time, if we run, you can see we got this hello world. But if we want to have this age function right here to run, if we run, it's not going to run because we have not imported that. But if we want to import that as well as this hello, but let's say we got some other functions here that we don't want to import them, what we can do is having this comma and then this age. And by having this, we're importing hello and age from this module. And now if we run, you can see again we got both of our items printing and both of our functions work. But Python itself comes with hundreds of built-in modules that we can use. And let's look at some of those items. And if you want to see what are those items, if you open your terminal, you can use this pipe right here and then this list. And if you use this, you can see it's going to list all of the modules that you have installed on your system and operating system. And these are the built-in modules that Python has. But you can see some other things that are only in mind, and you don't get these items if you install your Python directly on your system, because those are external that we're going to see how we're going to work with them and install them in minutes. So we exit our terminal, and here let's come and use few common built-in modules. And the first one is going to be our math module, which we can import that as well as our own modules. So we're going to have this math here, and this is going to import module for us, but not the codes and things inside of it. And this module has some awesome functions related to math that you can use in your code. For example, one of them is factorial, which if we want to use that, you're simply going to have some result here, and here we're going to use our factorial function in our math module. So we're going to have this math, of course, and then inside of this, we want to use this factorial. And for example, if we want to calculate factorial of 7, if we put that right here and then simply print that result into our output, you can see if we run, we got this result right here with only 3 lines of codes. And actually you can use this in your print. So if you want to have that like this, you're only going to do that in single line. And of course, you can use other type of importings. For example, if you want to use only this factorial, you can have this from math import, and then here you have this factorial. And if we come and remove this item from here, and for example, this time let's calculate factorial for number 10. If we run this, you can see we got this result right here. One of awesome and other built-in module that we got in Python is our random module. And for that, of course, again, we're going to import random, and then here we can have again our result, which we're going to use our module right here, and then we can have the simple print of our result. And let's clear our output, and now let's come here and let's say we want to have some random numbers between 1 and 10. So for that, what we can do is having this random, and then inside of this we got this rand_end function that we can use, and this is going to grab 2 parameters from us: the starting number, which I want to start from number 1, and then the ending number, which I want the numbers between 1 and 10. So if we put this, if we run this once, you can see we got this 8 number into our output. But if we run again, you can see this time we got this 9, and each time it's going to give us some different and random numbers. And as well as this, you can have some list to choose randomly from that. For example, let's say here we're going to have this list 1, and we equal that with string of characters. And now after we got that one, here we can use another function inside of our random module, which is choice. So we're going to have this dot choice here, and then we pass our list right here, which the name of our list is this list 1. And now this time, again, if we clear our output and run again, you can see first time it's going to give us this character of A, then it's going to give us A again, and it's going to randomly give us some characters. And those are randoms, and you can see until now we have not got any B's, but if you click, you can see each time you got some random item from this list. And of course, as same as the last one, you can use this from random, import choice, and here you only pass the name of the function and you don't need the name of the module. Or you can have simply this as rn, for example. And here you can have this import, and here instead of random, you put this rn. Again, it's going to run and give you different characters from your list. But let's say we want to use some modules that don't come with Python. And for that, we're going to use pipe. As you can see, we got terminal, and here if you use this pipe followed by 2 dashes and then this help, you can see the list of commands that you can run, and one of them is this install. And this is going to basically install a package and basically a module for you. So let's clear our terminal, and now let's import and install the requests module. which by installing this, we can call APIs and use APIs, which APIs is basically a connection between one application and another. So here what we need to do to install that is having this pipe right here and then this install. And here we're going to pass the name of the modules that we want to install, which in this case is going to be this requests. And you simply press enter right here and wait until the installation finishes. And after you installed this, if you check your pipe and then this list, you can see you got installed this requests module in your Python. And now let's close our terminal, and here in our file, let's import our requests module. And here you can see we got imported that, and for having some simple API, here you can simply search for JSON placeholder and come to this website that you see right here, which gives you free fake REST APIs that we can use in our example. And then here, if you come down, you can see we got this URL, which is our APIs. And if you grab this and put in your browser, you can see this is the thing that it's going to give us. The JSON, which has this user ID of 1, then the ID, title, and completed. But if you here remove this /1 at first and only have JSON placeholder.typecode.com/todos, if you run, you can see you got a bunch of those items. And basically, we want these items in our Python programs. So we want to grab these items. And for that, what we can have is come here and having our result variable again right here and equal that with this requests module that we got right here and then this dot. And inside of this, we're going to use this get method and function. And inside of this, we're going to pass the URL that we just copied. And pay attention, in this case, we're only getting that number 1, which was this todos/1. So we're going to get this item in our program. And because we want saved JSON format in our result, we need to have this .json at the end of that. And then here we can come and use our print method and simply print our result. And now here, if we run, you can see we got the same JSON right here. The user ID is 1, ID is 1, then we got this title and the completed status, which is false. And if you want to have all of those items and not only one of them, if we clear our output and run again, you can see that we got all of the items and not only one of them. But now let's say we want to create some simple program that we put the ID of the task and to-do that we got right here and we get only that in our output. And for that, what we can have in our single file is having this simple function right here of get task. And then here we're going to grab this ID from our user as our argument, and then inside of this we're going to simply return this request.get.this URL. But pay attention, here we want to have this ID, and for that we can use this f string. So we put this f here and then we got this slash and we can put our ID right here. And actually, instead of this return, let's save that in this result variable right here and then print that result into our output. And now if we come into our file scope and run our function of get task, and if we pass this number of 1, if we run this, and let's clear our output first, and if we run this, you can see we only get the user with the ID of 1. But if we put this ID number 10 here, if we run again, you can see this time we got the user with the ID of 10. And pay attention, we're searching for the ID and this is the field that we're looking for and not this one. So at the one above, you can see the ID is going to be number 1 and the second one, the ID is going to be number 10. But now after we got these items, let's create a mini program using our modules. And for that, here in our file, I'm going to get rid of this modules.py because we don't need this anymore. And then here, let's create another file, which this file's name is this hello. And then we got this .py extension right here, which in this one, we're going to have simple function of say hello, which is going to simply print this hello world. Then let's say we want to have another file in our directory, which this one is going to be, for example, users.py. And in this one, let's say we got some simple list, which holds our users' names. So this is another module which only holds data for us. And let's say we want another module, which this one is going to hold variables for us. So we're going to have this variables.py here. And here, let's say we got this A to be number 4, then the B to be this number 7, and some other ones. Just like this. And then let's say we got another one, which is our functions.py. And basically, in this scenario, we're going to save all of our functions in this functions.py except one function of hello, which is in our hello module. So here, let's say we're going to have some function to grab a list and show these items in our output. So for that, here we're going to have another function of show list. And here it's going to grab this list. And then here we're going to use simple for loop. So we want for item in list, and here we have the simple print, then this hyphen at first, and we add that with the item. And now after this item, let's say we want to have some things to do with our variables. So in our function.py again, we can have another function of add here, which this is going to receive 2 arguments from us, and then simply print this a plus b. And now we got these items in our functions.py. Now let's come into our main.py and use these modules. First one that we want to use is this hello.py. And pay attention, when you're importing the module, it should be at the top of your file and all of the importings at the top and then rest of the code. So here we're going to import all of our modules and see which type of importing is best for importing them. For example, in this hello.py, because we only have one item, it's good to have this from hello import this say hello. Then for the next one, because we got 2 items in our functions, we can use this from functions import 2 functions that we got was show list and add. So here we're going to have this add and show list. And the next one is our users and variables. And in our main file, this import of users, then we can simply import variables. And now if we want to use these items, for example, at first, let's run this function of say hello. So we got the say hello, and if we run this just like this, let's clear our output and run again, you can see we got this hello world, which we have misspelled this. So if we come again into our main file and run again, you can see we got this hello world. Next one, let's use our variables. Here we can have the simply print, and here we want to have this variables module, and inside of this, for example, print the variable of a. Now if we run, you can see we got the value of 4. If we have just as same as this but this b, if we run, you can see we got this number 7. And let's use this add function from our function module. And for that, we can have this add and pass this variables.a and this variables.b. And now if we run, you can see we got this 4, 7, and then our add function is going to add these 2 items together and give us this value of 11. But you can see this kind of writing the variables is not good. So let's pass some name to this. We got this import variables as nums, and here we can rename these items with this nums. And now if we run, you can see again we got the same result here. And pay attention, you can set names to these items that you're importing to. For example, in this case, let's say this as and sh. And if you run this sh function, it means say hello functions from hello module. So if we get rid of these items and run this sh, if we clear our output and run again, you can see again we got this hello world. And because in this variables module that we got, let's say we want to use all of these items, we can have this from variables import star, which means import all of them. And here what we can do is having this print, for example, and we can print all of them just by putting their name. And we don't need to have anything right here as module name or something like that. And of course, if you run, you can see you got all of those items. But at the last, let's use our list of users right here with this show list that we got in our functions.py. And for that, we have added this showList function from our function, so this is good. And then here we got imported users. So here we're going to use this showList function right here. Then we're going to pass our list, which is this users, and pay attention, this users is the name of the modules. And inside of this, we got our list, which lists rename this names. So if we come this name.py, here we can have this users.names. And now this time, if we run, you can see we got this Alice, Bob, and Charlie with this hyphens printing into our output. So modules keeps your code organized. And you can see the power of modules right here, that we got 5 file and module right here, and we can manage them very easily. For example, if we want to change functions, we can easily come here and see our function, as well as our variables, users, and other things. But if we want to have all of these items in one file, it will be like this. So we copy this from here. Then after function, we're going to have this function of hello right here. Then we should have this names. And after this, we should have this variables. And this is very hard to manage, looking for the thing that we got earlier, which we imported and used what we need. But pay attention, it comes to help when our program is large, and instead of having, for example, in this case, we got something like a 10 line of code, it might be thousands of codes. So it makes your code cleaner, organized, reusable, and enables theme collaborations, because when you got different files, for example, someone can work on the functions, the other one can be worked on other users and variables module, and you can do anything that you want. And actually, this system is the foundation for packages and frameworks like Django, Flask, and NumPy, which you can use to create backend server for your website or stuff like that. So at the end, for the recap, now you know what modules are, how to use built-in modules, how to import modules, how to create your own ones, how to use externals with pipe, and how you can organize your program using modules. In this part, we're diving into one of the most important skills every programmer needs: working with files. Imagine you're building a note-taking app or a logging system or just saving user data. At some point, you'll need to read and write text files. By the end of this video, you'll know how to open files, read their contents, and write into them. First, here in our file and folder, let's say we got this simple example.txt. And inside of this, let's say we got some random text. And now let's come back into our Python file, and now we can start coding. First thing that we want to do is how we can read content of our text file. And for that, first thing is to open our text file in our Python. And how we're going to do this? Well, first here, let's say we got this file variable right here, and then we equal that with this open built-in function that we got in Python. And here it's going to grab 2 arguments from us. First one being the name and the path of the file, and the second one is the mode that we want to open our file. But for this, because it's in the same directory, what we need to do is simply having the name of our file right here, which in our case is going to be this example.txt. And then here for the mode, because we want to read and get access to the content inside of that example.txt, we need to pass this R. And by only having this, if we come down and we got another variable of this content, then we equal that with this file, and then we use this .read method right here. And if we want to print that content, what we need to have is simply this print right here. Then we pass this content. Now if we run our code, you can see right here we got the text where inside of this example.txt printed into our output. And if you want to get rid of these extra lines and printings right here, what you can do is open your .run extension settings, and for that you can use the shortcut of Shift, Control, and X. And then here you're going to find this code runner extension that we got right here. And here if you click on this icon, here you got the settings. And if you come down, you're going to see this show execution message. And if you uncheck this one, you'll no longer have those items. If we want to check, let's get rid of these items and open our Python file again. So here it is. If we run again, you can see we only got the output and not extra things that we got earlier. But pay attention, you saw that we got printed the inside and content of this text file using our Python script and Python code into our output. But this is the point. Always when using files and working with files, remember to close that file. Here we open this file right here, and at the end what we need to do is target the file we have opened earlier and then use this .close function. And this is the safe way and right way of working with files and reading one text file's content. And if you don't use this close, there's going to be some problems further in your code. But we got some other types of reading than only this simple read function, which the next one we're going to cover is this read line. And by having this, if we run our code again, you can see this is going to grab us only the first line in our text. If we have our text file here in the bottom of our screen right here, you can see this is the first line that we got. So we got this one printing right here. And this read line basically reads one line at a time. What I mean is, first time this read line runs between of this open and close, it's going to grab the first line for us. The second one is going to grab the second line for us, and third one is going to grab the third line for us. So we're going to duplicate this item twice right here. So first time we're going to read, it's going to grab first one for us. Let's clear our output and run again. You can see first time it grabs the first line. The second time it's going to grab the second line, and third time it's going to grab the third line. Pay attention, we're not talking about how many times our code run, we're talking about how many times this function have been run in this file between of this open and close functions. But if you want to grab all of the lines in a list, what you can do is have this read lines method. And by having this, if you run, you can see you got a list of all lines. Here we got the first one to be the first line right here. Then we got the second line to be our second item, and third one to be our third line. But now let's say after we read our files, we need to write some data into our files. Well, what we can do for that is here, instead of using the read mode, we can use this W as overwrite mode. Pay attention, if we use this mode, our code is going to come and remove all of the things inside of this file and write new values. And for having that, what we need to do is simply having this file, then using this function of write. And here we're going to have this string of test from Python code. And pay attention, if we clear our outputs right here, if we run, you can see it got changed, this test from Python code. And pay attention, this is not output, this is actual file that we got right here. So this is going to change the file for us. And of course, you can have different codes. For example, we got misspelled Python here. If we make this correct and run again, if we check here, you can see again our code came and run and replaced and overrides the thing that it was in example.txt. But let's say we want to have this item remaining in our text file, but add some another thing into this. What we can do is using our append mode, which this mode is going to write to the end of the file, and the text is going to remain, and only we're going to add some other things. For example, let's say here we got this other text to be in file. Now, if we run this, you can see we got this test from Python code, and then after here, we got this other text to be in file. And pay attention, if you want to move this to one other line, let's remove this part right here. What you can do here is using this \n. And if you run again, you can see it goes to the new line. But another cool thing that we can have is read and write at the same time. And for that, what we need to have here is this R+. And by having this, we can read and write to the file. For example, here, if we have this simple read, and let's print this one into our output too. If we run this, you can see we got this test from Python code, another test, which is our file right here. And if we want to write something, instead of this printing and reading, we can have this dot right, and here we can have, for example, this numbers of 1, 2, 3. But let's say we want to add these items to the new line, so we got this \n right here, and now if we run, you can see it got some random thing into our output. This was not what we were looking for. And to fix this, what we need to have, let's say we got our original text right here, and we don't want that one to happen, and for that we need to first read our file. So we got this file.read, and now if we run this, because we have read that item and content inside of this text file, and then we're going to write this item and add this, it's going to work fine. Now if we run, you can see we got this 1, 2, 3 in its right place. And basically when you want to use this R+ mode, you need to have this read at the first, then this write, if you don't want to have some complex outputs. Now let's close this output right here, and we got our file down here. Now you know how to read and write text files, but this is some complex way of having this open and close function each time you're working with a file. If your code gets bigger, you probably forget to use this close at the end, and that's your application's and code's vulnerability and bug basically. But we got another cool syntax that we can use which prevent this bug in our codes, and that is using this with keyword at first. Then we use this open method that we talked earlier. Then here we pass the regular things that we talked earlier. For example, here we got this example.txt right here. Then we want the mode to be this R right here. And then here we got this as, and we pass the name for this opening right here, which we use this file. And this line basically is as same as we use this file variable and use our open method after this. But here we're not only creating variable, here we're going to have this columns, and we come into the block of this statement and line of code. And here we can do anything that we want. For example, we can have the simple print of our file. Let's read. And if we run, you can see we got this result right here in our output. Or if we have this override mode, we can have this that's right, and we can have this Python to be override this item. If we run again, you can see we got this Python overriding the actual text that we got earlier. And this is basically automatically closing our file for us and cleaner and safer to use. But let's say we don't have our file and text file in the same directory as our Python file. How we can move this? Well, that's as simple as using files in any other programming language, or actually any part in any computers. For example, let's say we got this text here and we got this file inside of this text. If we move that to there, what we need to do instead of this, let's say we want to overwrite this number 1, 2, 3 again. If we run this, it's not going to do that for us. So we're going to have this text / this example.txt. If we run this, here you can see we got changed this item. But in some other cases, we want to create other file. For example, let's say we remove this text folder and example text inside of it, and we got only our Python file right here. But we want to have, for example, some users.txt, and we want to write some users data in that. For example, let's say we want some simple names. Let's say we got Tom, Ted, and John. Now, if we want to create this file, what we need to do is only using our W type. And now if we run, you can see it created this text file for us. And if we open this, this is the result and text that we want to save in this text file. But what happened if we accidentally misspelled this item? For example, let's say we want to change these items to be only Tom, but instead of having this users.txt, we misspelled this to users and then have another extra s right here. This file is not exist. And if we run this, again, it's going to create another file for us. But we don't want this to be happen. So we remove the second file, and we need to check this file exists or not before using this item. And for that, we need to import some module and library first. So we're going to import this OS. Then we're going to have this if statement right here. Then we're going to use this os.path.exists function. And then here we pass the path. So here, if we have this users.txt, of course, as string right here, then let's comment these items out for a moment. If that exists, print exists for us, else print file not found. Now here, if we run this, you can see we got this result of exists because we got this file right here in our folder. But if we have some misspelling right here, for example, this double S, if we run again, you can see we got this file not found. And the way that we're going to use this is simply have this path variable right here. Then we equal that with this users.txt. And here, instead of having this string, we're going to use this path. And then if that exists, we want to run these code that we got right here earlier. So we got this with open users.txt, and we need to replace this with this path too. And then we got our same else part right here. Now here, if we want to, for example, change this users of Tom, let's have that item and text file here too, like this. First, let's say we got some wrong file name, for example, this user double S. If we run, we got this file not found. But if we correct that and run again, you can see we got our success and our file has been changed to this Tom. And basically this was it. In this part, we covered how to open, read, and write files into Python. You learned about the file modes and even this with open keyword. CSV files, the most popular file format in the world. If you ever exported data from Excel, a database, or Google Sheets, probably it was CSV files. But how we can work with CSV files in Python. By the end of this video, you'll know how to read and write and work with CSV files in Python. Don't forget to like and subscribe, and let's dive into the video. Now here, let's first cover what is CSV file. Well, CSV stands for comma separated values, and it basically stores tabular data, which is rows and columns for us. And it can be opened in Excel, Google Sheets, or in the text editor. For example, here I got this example.csv right here. And if I reveal it in File Explorer, you can see I can open that with Excel. And basically this is the file that we got. We got some names, some age, and grade for each item. But if we open this item in text editor, it's not going to show like that. It's going to show like this, and actually this is the way that our CSV files save in our storage. And it's going to have this first line as header for the content, and each line is going to be one row of data. And these commas separate these values from each other. And as you probably guessed, the first one is going to be name, the second one is going to be age, and the third one is going to be this grade. But now let's say we want to open and read our CSV file in Python. For that, first thing that we need to do is this importing of CSV. And this module is Python's built-in module, and we don't need to install anything. Then we can come here at the next line, and as we open the file in the last part, we're going to have this with keyword at first, then we're going to have this open, then we open our parentheses, and here we're going to pass the name for our CSV file, which in our case is going to be this example.csv. And then we're going to have the type and the mode that we want to open this, and it's going to be this R as read. And then we pass this as file for simpler using, which when we refer to this file variable, we mean this file that we just imported. And then we can come into this block, and then we create this reader variable right here, and we equal that with this csv.reader. And this function is going to grab the file for us and save that in this reader variable. And then if we simply have this print of our reader and run our code, you can see we got the csv.reader object. But how we're going to open and print the data inside of this object? Well, for that, what we need to do is simply having this for loop right here, and then we tell for row in this reader, we want simply this print of our row. And now this time, if we clear our output and run again, you can see we got this result in our output. And if you pay attention, it's going to grab each row and give us that row as a list and show that right here. And all of the values are string by default. Even we got these numbers, those are going to be strings too. And we got our header row at the top and then the items and data below that. But now let's say we want to create some simple CSV file from scratch. And for that, you can see we got this example.csv right here. And pay attention, for this part, we put the URL and the path to this file from this Python file that we're working with. So it's going to be right here. But now let's say we want to create another users.csv right here. And for that, what we need to do is have this W as mode for opening. And if you're working on Windows system, it's good to have this new line right here and equal that with this empty string. And this is basically prevents extra blank lines in Windows. And then we open it as file as we done it in the read part. And then here, instead of these, we're going to have this writer variable right here. And again, we're going to use our CSV module, and inside of that, we got this writer function. And then we pass the file for this, and here after that, we can write new rows in our new file. And pay attention, our first row must be header. So here, if we want to start writing new row, what we need to have is using this writer variable that we got. And then we put this dot and use this write row function inside of it. And then here we got our parentheses, and here we're going to pass simple list. And here is where we're going to pass our items. For our item and our example, we're going to have the simple name, and then we separate this with another one, and this one is going to be this ID right here. For the next line, again, we can have this simple writer that writes row right here, and we're going to pass this list inside of this function. For example, we're going to have this Alice, and let's have the ID of 1 for this person. Then we can have another person of Tom, for example, with the ID of 2, and going on. And now if you look here, we don't have any extra files right here, but as we run this file right here, you can see we got created this users.csv. And if we open this in our text editor, you can see we got our first row as our header, which got this name and ID, and then all of the values that we put right here. And of course, you can open this in other applications. For example, let's open this in Excel. You can see we got opened that just like this as we want. And of course, we can read this file again too. What we need to do is simply having this users.csv. Then we change this type of this W to this simple R, and then we don't need this new line. And here we can have this reader right here, and we equal that again with the csv.reader. We pass the file here, and then we have our for loop, which we got this for row in reader. We want this print of our row. And if we comment these items out just like this, if we run again, you can see we got the results that we put earlier in the file and code right here. But in some cases, in your CSV files, you want dictionaries instead of these lists right here. And for that, what you need to do is not very hard and complicated. You just need to change this function right here to this dict reader. And then if you have this row and in reader, if you print this row, if we remove our output and run again, you can see we got dictionaries of each row like this. Each row is going to contain the header of that item. For example, this name is Alice and the ID is 1. The second one has the name is Tom and ID is 2. And you can use this type of dictionary to work easily with your files in your program. And if you only want to have, for example, the names and not the IDs, what you need to do here in print, you put this row and then inside of this only print the name column, for example. And if you run this, you can see you only got the names and not the IDs. And of course, you can have the reverse of that like this. And basically, by having this, you can print only the column that you want and none other things. And if you want to write with this dictionary type in this format, What you need to do is having this W here again, and then we got this new line for users which has Windows. Then inside of this, we're going to have our header right here. And pay attention, this is variables and this has nothing to do with our file yet. And for example, here, let's see what was our headers. It was name and ID. Here, we're going to pass this name and then this ID. And then here, we're going to have our writer variable right here. And inside of this, we're going to use the csv.dictWriter. And again, this is function. And inside of this, first thing that we need to pass is our file. And the second one that we want to have is telling our Python and our code and our file what is our field names. And we're going to have this field names and equal that with our header right here. Of course, you can have this array and put that here too, but if you want cleaner code, it's better to have them separated in another variable and simply put the header right here. And then after you got that, you can have this writer, and inside of this, you can have again this write row. And here, instead of passing the list like last time, we're going to pass this dictionary. And it's going to have this name of our user. For example, let's say we want this John. And then let's say we got this ID right here. And we want the ID to be number 6, for example. And now, if we open our users, the CSV right here under our main file and run our code, you can see it overrides the thing that we got in our file. And it's going to put this John with the ID of 6 right here. But if we want to append this item, what we need to do is having this type of A instead of that W. And this time if you run, you can see you got appended and added this John with the ID of 6 at the end of your file. But you might get some errors using the CSV files. And the common error and issue, one of them which we have talked about, is this new line which is in Windows and it fixes the blank lines in your CSV files. The other thing that you might get is encoding problems, which if you want to get rid of that problem, what you need to do is here, after putting your file names and mode for opening them, you can have this encoding and equal that with this UTF-8. And this is going to basically get rid of your encoding problems. And the next thing that you need to pay attention to is our numbers are going to be in strings when we read them from our CSV files. So if you want to use those numbers, you need to convert them into type of number from string first. And the real life use cases for this kind of stuff that we learned in this part is for data analysis, exporting and importing user data, saving logs in structured format, or moving data between apps. And now you know how to read, write, use dictreader and dictWriter in CSV files with Python. In this part, we're going to talk about try exception in Python, and we're going to see what are the difference between exceptions and errors, how to catch and handle exceptions using try and except, how to use else, and finally, and at the end, how to create and raise your own exception. First thing that we're going to have is explanation about the exception. Basically, exception is an error while our program is running. You know, we got our syntax error. For example, if we want to print some word, let's say here we want to print this simple Python word in our output. If we run this, you can see it's run successfully like this. But if we have some syntax error, for example, we missed this parentheses right here at the end, if we run again, you can see we got this syntax error. But these errors happen before of our program, and our program can't be run if it has the syntax error. But in some other cases, we got something in our program, and while program running, we got some error. And that is our exception. And we got three types of exception, which first one is this zero division error, which occurs when we want to divide some number by 0. For example here, if we have this number 5 divided by 0, if we clean our output and run again, you can see we got this error of zero division error, which is our first type of exception. Then we got this value error, which occurs when we want to change the type of string to number. You know, if we want to change type of string, we use this int here, and then we put the string which has number inside of this. For example, if we have this number right here and simply print this into our output, If we run, you can see we got our result as number. But let's say we got some word here instead of that number. If we have this Python, this can't be changed into the number. If we run this, our program runs, but it got this value error, which is our second type of exceptions. And then at the last, we got our type error. And this occurs when we want to add some numbers with some string. If we have number 5 right here, and we want to add that with this string of 5 right here, if we run this, you can see we got this another error of type error, and we can't add int with string. But you're going to see we're going to create our own exceptions in our program, which is very helpful for maintaining and using and coding our projects. But how we can control these exceptions to not occur and stop our programs? Well, here is where our try except come to place. And for that, we're going to have this try right here as our keyword, and we got some block right here. And this is where our main program and risky part of our program, which may have some exceptions, come to place, and we put that here. For example, here, if we got this 5 divided by 0, you know we got some error. But for handling this, what we can do is having this except right here. And this is going to grab the error that this part inside of this try is going to give to us. Actually, let's have this print of try part right here to see this right here, and then we're going to accept the type of error this is going to give to us. For example, in this case, it's going to be this 0 division error. And then we put these columns right here, and inside of this block, we're going to write the code that we want to run if we got this error. For example, we can have this print as message. And now this time, if we run, you can see instead of crashing our program, we got this try part run, then we got our message, which we need to correct this item here, you got number divided by 0. And after this, you can run the other codes right here. For example, let's say outside of our blocks, we want to have some other prints to say that this is the rest of program. And you can see if we run this, we got these errors right here. But again, we are able to run the rest of our program. But in some other cases that we don't use these items, if we got this 5 divided by 0 right here, and let's actually save that in some variable to see that's not syntax error. And now if we run again, you can see we can't come into this line and run our program. But by using this try except, we're able to do that item. But if we want to have automatically this print and not writing ourselves, what we can do is having this as right here and putting some name. And simply this is going to be some kind of variable holding this error. And here, instead of printing this, we can simply print this E. And this time, if we clear and run again, you can see we got this error of division by 0. You can see here, we don't have any strings here in our print, but this is going to come automatically from this part. And of course, we can have other type of exceptions right here. For example, let's say we got this typecasting of the word Python. If we got only this line right here, as simple code, you can see we got this value error. But if we come back into our syntax, and here instead of listening for 0 division error, we want to check for the value error. And this time if we remove and run again, you can see this time we got this error right here, and again our program runs. Pay attention, if you got this 0 division error and don't have that 0 division error and have this value error right here, if you run, again your error is going to cause this problem and stop your program. So pay attention, you need to target the type of the error that you have. And another type of exception that we got was adding some number with some string. For example, let's say we add this one with this AST. And that is of course our type error right here. And if we clear our output and run again, you can see we got this error message printing right here. But while we're coding some programs, we don't know what error we might get in our programs in some scenarios. For example, if user is going to put some numbers and we deal with that number, we don't know what error and what exception that one is going to give to us. And for that, here we can have this simply exception right here, and this is going to grab all of the 3 types of exception that we got automatically and handle that for us. For example, in this case, here you can see we got this type error. If we run, you can see we got that cached right here, and still we got rest of our program running here. The other type was our value error, so we got this typecasting of this test word, for example. If we run this again, you can see we got handled the error and again run our program. And the last one was our division by 0, which here let's say we got this 5 divided by 0. If we run again, you can see again we got this error handled and we got the rest of our program. And the same, these two lines give us 3 different handling, error and exception for us. But if you want to behave differently on each exception, you can have all of them in separate except part. For example, here we can have this value error, and here we print the simply value error. And just as same as this, we can have 2 other excepts right here. And other one is going to be this 0 division error, which we're going to print that one into our output too. And at the last, we're going to have this type error. And again, we're going to print in our output. And we can have some space and blank lines between our error handling and other part. And for that, what we need to do is this simply \n. And now this time, if we got this 0 division error, if we clean our output and run again, you can see we got this custom message right here. If we got, for example, this wrong typecasting, if we run again, you can see we got this value error. And if we want to have this type error of 1 plus string of 2, actually this should be 1. And if we run again, you can see we got this type error. And we can behave differently on different type of exceptions. But after using our try and except, it's not very professional to have rest of your program here in the outside of this try except block. And maybe you want to do something if you got this error, and you want to do different thing if you don't have error. For simplicity, we're going to remove these items right here and simply receive our exception right here. And then we're simply having this exception here too. You can see if we clean our output and run, still we got this exception word as our error right here, but we got this rest of our programs. But let's say instead of having this rest of program, we got some codes which we want these lines if the program got no errors. You can see if we put like this, if we run, we handle the error, but again we got this one printing. And for doing the thing that we want right here, we need to have this else. And again, inside of this else block, we can have the codes that we want to run if our program got no errors. So we got our main and risky code right here. If inside of this we got some error, this part is going to run, and if there was not errors or exceptions here, it's going to run this part. And this time, if we clear our output again, you can see this time we got error. If we run, you can see we got this exception right here. But if we don't have this error and run again, we got this line of if the program got no errors, run successfully right here. But again, we don't want to have the rest of the program being right here. And actually, we got some keywords for this item too, and it's going to be this finally. And basically, the code inside of this finally block is going to run no matter there was error or there was no errors. But let's say you want to create your own type of exceptions and don't limit yourself for only 3 types of exceptions. And for that, what you can have is, let's say first we're going to have some simple program. We want to have this try at the first for the risky part, of course. Then here we're going to have this age variable. Then we equal that with this input and we ask user your age. Of course, we can have this if statement right here to check if age is below 0. We tell to the user age cannot be negative. But where our try and exception part come to place? Well, here let's say we're going to calculate some simply results. And we got the variable of result, and we want to get, for example, some number. For example, this 100 divided by this age. If it's going to be 0, our program is going to crash. And if it's going to be negative, that's not the right and correct logic that we want to have here. So for preventing the user puts the 0 as the number, we can have this simply except right here. And we put this 0 division error. And then inside of this, we can have this simply print, and we tell user age can't be 0. And pay attention here, we need to change the type of this age to the number, because when we grabbing this input, it's going to be a string. So we're going to have this int right here and then convert this age. And now here, if we want to run and pay attention, because we got this input statement in our Python file, we cannot run that using run extension. Instead of that, we're going to run our program in terminal. And in VS Code, you can press this Ctrl J to bring up your terminal. And here we can have the simply Python and then the name of your file, which mine is this main.py. And if we run this, it's going to ask for the age. If we put, for example, 12, if we run, actually we got error here because we have not saved this int type of age to this age variable. And here is going to grab still this string type. So here, instead of using this type of syntax, we're going to have this age right here and we equal this age with integer and number type of this age again. And now this time, if we run again, if we put, for example, this 12, if we run, it's going to run successfully. And actually, let's say here, we're going to have this else part right here that we're going to print program executed successfully. And now if we again repeat those process, you can see we got this program executed successfully. But if we clear our terminal and this time we put this 0, it's going to print this age can't be 0. Because we got this 0 division error handling right here. And if we got some negative numbers right here, for example, this minus 12, if we run, you can see this age cannot be negative printing right here, but still we got this program executed successfully. But we don't want this thing to happen. And for that, what we can do is creating and telling our program that this is the error that you should pay attention and stop the program and don't run the else part. And here, for that, we're going to use this raise keyword right here. And then inside of this, we're going to have one of 3 types of errors. For example, in this case, let's say we got this value error. Then we open our parentheses and here we pass the message that we want. For example, in this case, it's going to be this age can't be negative. And now here we got the 0 division error here is going to be at its place. And then we're going to have another exception handling, which this one is going to be this value error. And this time, instead of having this, we can accept this as this VE as value error. And here we simply print this VE. And this time, if we again come into our terminal, if we clear our terminal again, and let's run our program again. Here, if we put this 0, we got this age can't be 0. If we run again, this time if we put this negative numbers, if we run, you can see that we got this error of age can't be negative, and this actually stopped the program for us and we don't run the rest of program right here. And of course, you know that we can have this finally right here, and inside of this, we can have anything that we want to run no matter what happens. So let's say here we got this program finished. And this is going to run always. So this was it. Now you know what exceptions are, how to catch and handle them, and how to use else and finally, and even how to raise your own exceptions and create your custom error handling. In this part, we're going to see how we can model different real things in Python. For example, if we want to save cars, students, or even bank accounts. They all have their own data and behavior. And that's where our classes and objects come to play. You know that we got several data types in our programs and Python. For example, we can have this simple a variable right here and we can save some number inside of this. Or we can have some other variable and we can save some simple strings inside of this variable. But think of this way that we want to save some students' data in our programs. For example, we can have this student number 1 and we equal that with this dictionary, of course. And then we can have, for example, this simple name for the John, age for 25 and going on. And this is our simple dictionary. And you already know this is a better way of doing something like this, that we got this student 1 name to be some other variable. For example, let's say again John right here. And then we can have this student 1 age to be 25. And this is better way. But we got the better way than this option too. And that is by using our classes and objects. When we defining class, we simply creating a blueprint like a template, and basically it's going to be our own data type. For example, let's say we want to create this class of student. What we can do is having this word of class right here, and then we pass this student word right here. And then inside of this, of course, we can have some other codes to be our template. And here inside of this class, we need to have something called constructor. And that's basically this simple function, which has this def keyword right here. Then it's going to have this 2 underlines, then this word of init, and 2 other underlines right here. And then after this, we're going to open our parentheses, and here inside of this, we're going to pass the name of our attributes. You know, here in our student 1, we got this attribute of name to have the value of John, and this attribute of age to have this value of 25. So here, we're going to pass those items. But pay attention, before those items, we need to have this word of self right here. And the self basically is going to help us to define and pass values like this John or 25 to our attributes. And then after this, we're going to have our name and age right here. So here we got our name, and then after this, we're going to have our age. And then here we're going to have these columns right here. And then inside of this, we're going to use this kind of syntax. First, we're going to use our self keyword, then we use this dot, and then we select the attribute inside of this class. You know, here we got this student, and here we got this name and age for our student. So we use this name, and pay attention, when we using this, you know, by highlighting, our self is being used right here, but this one has not been used yet. And that's because we need to equal that with this name. And we're going to do the same thing with the age too. And pay attention, this constructor function is going to run when we want to create something and some object from our class. So when we're going to use this class of student and create some object and some students, this function is going to run automatically, and it's going to grab the name that we pass while creating this into this part right here and put the value of the name in the attribute of this self and class to be this name. And the same thing for the age too. And for creating object, what we need to have is simply having the name for our object. For example, I want to have this S1 right here. Then we equal that with the name of our class right here, which this one is going to be this student. And then we open our parentheses and we pass the name and age for that student. For example, in this case, let's say again we put these values. So we got this John to be our name, and then we got this 25 to be our age. And now let's get rid of these items at the top of our file. And now by having only this, we got created object from the class of student right here. And pay attention, this is going to be function as you see. And when we calling this, it's going to come and see this student class right here. Then run this default constructor function right here. And then here, when we pass this John, it's going to be this name right here. And when we pass this 25, it's going to be this age. But pay attention, this part is where it's going to define these values to class and create object for us. And if we want to see what this actually does, let's say instead of creating these items right here, we only have print of this name and age right here. So we got this print simply like this. And now if we run our code, you can see when we're creating, it's going to run this function and it's going to print this name and this age for us right here. But let's say we want to access the name for our student 1. And if we want to do that, here we can have this print of s1.name. And this is going to grab the name for this s1. But here, if we run, you can see we got this error right here because we have not defined this name to this s1.name. And to do that, as you know earlier, we're going to have the self right here and put this dot name and self.age to the age. And this time, if we clear our output and run again, you can see we got our s1.name right here. And as well as this, we can have our s1.age too. And if we run, you can see we got both of those items. And of course, you can have other types and other attributes right here too. For example, let's say we got another one, which is this gender. And here, of course, we're going to have this self here, and we put this dot gender to this gender right here. And here we can pass the gender, or we can have anything that we want. For example, in this case, if we put this male right here, if we want to print the gender of our user and s1 object, if we have this right here and run, you can see we got this male right here. But let's say instead of this gender, we're going to have this right-handed. And of course, we need to change this item right here too. So we're going to have this right-handed here too. And let's say we want to have the default value for this item to be true. So if we don't put yes or no right here, we get this true right here. And for that, here we can use this true right here, and by having this, it's automatically going to grab this true unless we put something else. What I mean is, let's say here we got another printing of our right-handed situation. If we run this at the first, you can see we got this true. But you see here we don't have anything referring to our right-handed attribute. But if we have this false value right here, if we run again, this time it's going to override this one and give us this false. And for the other parts and other things that you might have is, let's say you want saved school for students, and school is going to be saved at all of them. For that, you don't need to have another attribute right here and have its default value, because it's not going to change. For that, what you need to do is having the self and put this dot, and here you put this simply school, and you equal that, for example, with this school 1. And now by having this, all of the students which are going to be created using this class of student are going to have this fixed value for their school to be this school 1. And here, if we want to check that with our S1 here too, what we need to have is simply this print of school. And now after having this, if we run again, you can see here we got this school1 default in our object. But the main usage of creating classes is to be able to create multiple objects from this one class. So this is our data type for our student. All of them is going to have the name, the age, the situation, if they are right-handed or not, and the fixed value for their school. And let's say we're going to have this other S2, and it's going to have this Jane, which has 22 years old. And again, we can have another S3, and this one is going to be some different thing. And pay attention here, if we have this print right here, we can have, for example, this S1.name right here. And if we clear our output and print, you can see we got this John. For the second one is going to be this Jane. And for example, let's say for the third one, we want to grab the age instead of this name. If we run again, you can see we got this 23. But let's say we want to show all of the details related to one student in one simple line. If we put this, for example, S1 right here, if we run this, you can see we got this object of student, and it's not going to show us anything. For that, what we need to do is creating another function inside of our student class. And here we're going to have the simply def, and we're going to use this display as our function. And here we're going to pass the self. Pay attention, what the self does here is going to grab the items and the object which this class of student has right here. So we can use these items and these attributes inside of this function too. And then inside of this, we can have the simply print of f string of name equals the name, age equal age, and right-handed right here, as well as the school. And now this time, if we clear our output and we want to show that, what we can do is using this S1, which is our object right here, and all of these objects are going to include this display function as default. So we don't need to have this print anymore because we got print right here. We have this simply S1.display. And now if we run this, you can see we got this beautiful result right here to show the name, age, school, and if he or she is right-handed or not. And as well as this, of course, we're going to have two other things of S2 and S3 right here. And if we clear again and run again, you can see these results right here. First here, we got our first object and first student. Then we got our second object and second student, and our third one right here. And basically, you can look at these code like this, that attributes are going to store data for us, and these functions are going to define the behavior for our object. And each object, of course, is going to behave based on its own data. For example, if we want to display items from S1, it's going to come into this S1, run the function of display in this S1 object, and in that object, the name is going to be John and age is going to be 25. And that's why we got this John and 25 right here. In the second one, we got this Jane and 22. And you can see we got this Jane and 22. And at the third one, as same as these two previous items. And if we want to check some real use case of these items, what we can have here, instead of this function of display, we can have this function of isPassing. And this again is going to grab the self right here. But here, instead of having these much of item right here, what we want to do is having only the name and then this grade. And of course, we need to have the self.grade right here to equal with this grade again. And here inside of our function, we want to check if the grade is above 50. So we have the self.grade right here. If that's above 50, we want to print this simply password right here. And at the else part, we want to print this failed right here. And now for checking that, we need to create object, of course. So we're going to have this S1 to be equal to this student again. Then inside of this, we're going to have the name. For example, let's say we got this Ted right here. And for the grade, let's say this user and this student got the grade of 60. And let's say we got another object. This is S2. The name is going to be Tom, for example, and the grade is going to be 30 here. If we want to check if these students are going to be passed or not, what we can do is simply having this S1.isPassing, and if we run our program, you can see we got this pass because our user and student of that got the number and grade of 60, and that's above 50, and the user can be passed. And if we want to check that with our second user, so we got this S2 and run this isPassing function that we just created right here. If we run again, you can see we got this value of failed because this student got the grade of 30 and that's not the minimum grade for passing. And another thing that we are able to do here is change the value and attribute of these objects after we created them. For example, let's say again we got this S1 to be this student and it's Alice with the grade of 90. And as well as that, this S2, which is again student, Bob and 85. And here, we can have this another function of display, for example, and having this F string right here. And here, if we run this S1.display as well as this S2 display, if we run, we got these items. But let's say here, after we created our objects, we want to change Alice's number and grade. For that, what we can do is having this S1 and then we put this .grade right here and we pass this 95. And this is actually going to update Alice's grade. And as well as this, we can have this S2.name, for example, and change the name of our S2 student into this Robert. And now if we run again, this time you can see the Alice's number changed from 90 to 95 and the name of this student, which was Bob, has changed to this Robert. And of course, you can create other attributes here too. For example, in this S1, we can have this S1.gender and we equal that with this female. And let's get rid of these displays right here. And if we come here and simply print this S1.gender, if we clear our output and run again, you can see we got this female. But if we do that with our S2, because we have not defined this gender to our S2 student, if we run, you can see we got this error coming up. In this video, we're going to talk about instance vs class variables and to see what are the difference between these two items, and we're going to create and code mini project of bank account at the end that you will see how objects and classes works in real life. At the first, we're going to create our class, of course, which if you're not familiar with classes and objects, you should watch the previous part first and then come to this one. So here we got this bank account class right here. Of course, here we're going to have our constructor and init function right here. And here we're going to have the self, then our parameters and attributes, which in our case is going to be this owner at first, and then the balance. And for the balance, we want the default value of 0 right here. Then inside of this item, we're going to have these two lines to set the owner and balance of the object to these variables that we passed right here. And then here we're going to have another function with the name of info right here, which here we're going to have the self, of course, and inside of this, we're going to use the simple print of our f string, and we're going to say the self.owner has self.balance in account. And now if we come here below of our class and let's create some objects. For example, we got this account1, we equal that with our bank account, of course, and here we can have some users. For example, the first one is going to be this Tom. Let's say he got $100, and let's say we got another object of count2 right here. And here again, we got this bank account, but this time the name is going to be this Alice, for example, and then let's say she got $200. And now if we want to use our info function, which we declared right here, we simply are going to use this acc1.info. And now if we run our code, you can see we got this result of Tom has 100 in account. And as well as this, we can have this number 2 to run. And again, we got this Alice has 200 in the account. But let's say we want to declare and show the bank's name in the class and objects too. Of course, we can have this self.bankName, and we equal that, for example, with this Python bank. And by having this, if we want to show that to our user, so here we got this account1, and if we use this bank name and print this item, you can see if we run, we got this Python bank. And if we got this account2 instead of account1, if we run again, we got this Python bank. And actually, these are our instance variables, which are the variables that creating when we create some objects. But in some cases, we want to have this kind of fixed value in our objects and classes. And for that, it's good to use class variables instead of those instance variables. And the way that we're going to create that, here inside of our bank account and class view and scope, we're going to declare our variable. For example, in our case, it's going to be this bank name. And here we equal that with our value, which in this case, again, it's going to be this Python bank. And now if we update this because it's lowercase this time, if we run this, you can see we got error because we need to make this n uppercase too. Now if we clear our output and run again, you can see we got this Python bank. And if we change this to account1 and run again, we got this Python bank right here. And if we want to change this item, for example, let's say here, we want to change the name of this bank name. If we use this acc1.bankName and equal that with this test, for example, if we come here and again print both of our objects bank name, so we got this account1 bank name, and as same as this, we got this account2 bank name. If we run this program, you can see at the first one is going to be this test, but second one is going to be this Python bank. And to fix this, what we can do is instead of using this object's name, we use the name of our class, which in this case is going to be this bank account. Now if we clear again and run, you can see both of them has been changed to this test, because when we're creating this, it's going to be this Python bank for both of these objects. But when we change the bank name of class bank account to this test word right here, it's going to rename all of the bank name variables in all of the objects for us. And because of that, in both of our account1 and account2, we got this new value. And these are called class variables, which basically class variables are the variables shared between of the objects, and instance values are the values and variables for only that specific object, and it's not going to be shared between other objects. And another cool real-world example of this type of variables and class variables is showing the total number of accounts. So I'm going to put the name to this total accounts, and we equal that with the 0 at first. Then here in our constructor, when we want to create some object and account, we're going to grab this item right here and add one to this one. But if we use the self.total account, it's going to do that for only one object, For example, here, if we use this and use this plus equal right here and this one, you can see we got two items. If we get rid of these items right here and we don't need to change this item again, let's say instead of those, we got this print of our class of bank accounts, total accounts. If we run this, you can see it got this 0. But you know, when we created these items, we added to this item. But if we check this account 1 and run again, we got this value of 1 as well as this account 2. And if we run this, we got this value of 1 again. Because when we're using the self, it's going to refer to only the object, and the total accounts variable inside of this object is going to be number 1. So instead of using self here, again here, we're going to use the name of our class, which in this case, again, is this bank account. And this time, if we clear our output and run again, you can see we got two number of accounts. And if we got another account right here, for example, this account number 3, we equal that with our class name here, and we created one other for the John, for example, and let's say he got $500. If we run again, you can see this time this is number 3 for the total accounts. And the next thing that we're going to talk about, you know that we got the simple functions that we can work with the self keyword and instance values right here. But if we want to do something with our class variables, what we need to do is here, instead of creating that kind of simple and basic function, we're going to use this @ sign here and then use this class method. And then below this, we're going to create our class method and class function, which this item works on the class itself and let us update or work with class level data. The example for this is, let's say we want to print something using these two items. So here we're going to have this def and we got this name of bank info for our function. But pay attention, the difference between of this class method and regular method is here, instead of using the self like this one, we're going to use the CLS keyword. And then inside of this, we can have whatever that we want. For example, let's say we want to have again this simple print of this F string, and here we're going to say the name of the bank. So we got this curly braces, then we got the CLS.bank name, then we got this has, and again we got this CLS.total accounts, number of accounts. And now here we got 3 accounts. If we get rid of this print, and let's say here we want to have simply this bank account dot bank info for our function. If we run this, you can see we got this function runs and tells to us Python bank has 3 number of accounts. So at the end, for the recap, we got these two items as our instance variables, which are going to be different for each of our accounts right here, and they're going to be only for the object and not for the class. Then we got these class variables, which these one are going to be shared between all of our objects, and all of them are going to have these values, and we can work with these items. And then we got our regular method and function right here to use our instance variables, and we got our class method right here, which just got the CLS instead of the self, and we can use this to target class variables instead of these variables, and we can work with those items and class level too. In this video, we're going to talk about what is the encapsulation and private members in Python, what are the benefits, and what is the analogy and concept of this part. And then we're going to see our 3 types of encapsulation and privating, which are these public, protected, and private. And then we're going to see how to use getters and setters to deal with our private members. And at the end, we're going to talk about this awesome property decorator, and we're going to see how this is going to help us to code and develop applications very efficient. Well, at first we got this word of encapsulation, and the meaning of this basically is hiding internal details of an object. For example, think of this way, that we got our file like this, and then inside of this we got bunch of classes and some subclasses inside of these classes, which we're going to talk about these parts and subclasses. Basically, these are in part of the inheritance, which we're going to talk later. And you know, we got some values in each of these items. But we don't want any item and any file and any part of this program has access to another parts. And we can compare this with our scope. It's very similar right here. So for code example, let's say we got the simple class of bank accounts right here. And inside of this, of course, we need to have our constructor and init function. So here we got this init, and here we're going to have the self. Let's say we want to have this owner and simply balance right here. And inside of this, we're going to have this simply self.owner to be equal to this owner as well as the balance. And you know from earlier parts that we can have this simply object of account 1, for example, and we got this bank account right here, and we have the name, for example, let's say this Ted, and let's say we want to have 3,000 for the balance. And now you know we can simply have this print, and we can use this acc1.balance right here. And if we run our program, you can see we got our results right here. As I told you earlier, in encapsulation in Python, we got 3 general types, which first one is going to be our public items. Then we're going to have our second item, which are the protected, and then at the last and third one, which are our privates. And pay attention, these items are going to be applied to these attributes and values or our functions. But how we're going to set and say to our program, for example, this balance attribute is public, protected, or private. Well, we're doing that by underscores before of our variable's name. If we don't have anything right here, it's going to be our public. So the public is going to be simply var name like this. Then for the protected, what we need to do, instead of having this simply var name, we need to have one underline right here, then the var name. And for private items, we need to have 2 underlines here, then the variable's name. And by this rule, you know that this time this is our public. We can access this right here. And then another thing that we can have, for example, we got another method right here of show balance, and it got the self, of course, and inside of this we simply have this print of self.balance. And if we get rid of these empty spaces right here, you can see if we clear our output and run again, we got this item printing right here because of this. But if we remove this and use this acc1.showBalance and run this function, if we run again, we again got the balance of our account. This public one is going to set our variable this rule that it can be accessible from anywhere in our program. But this protected one is going to hint us that this should be used only inside of the class or subclasses, and we don't want to use it outside of this class. For example, if we have this underline right here as well as this, so we make this balance variable this protected. If we run again, you can see we got 3,000 because of this show balance, and this function is going to use this item. But instead of this, if we want to have this print of simply this account1.underline balance, we clear output and run, you can see again we got this result coming up. But you know that we talked about this and we say this is good for using inside of the class. And actually Python don't restricts us and gives us hard rule of we're not be able to use this outside of this, but this underscore right here is something like a little hint or note for ourselves that we want to use this attribute and variable only inside of our class and not through all of our program. But unlike this, with private members and private attributes, Python itself don't allow us to use this outside of this class. For example, you can see if we use this count1 double underscore and then this balance, if we run this, we got this attribute error of this bank account object has no attribute of balance. But you can see we got that, and that's our Python's privacy and encapsulation that won't let us do our thing. But if we get rid of this print right here and instead of this we use this account1.showBalance, if we run this, you can see we got this result. Because we can use this inside of our account and class, but we can't use that outside of this. And we need to use this kind of function to be able to do that. And for a little recap, if we use this single underscore, it's going to hint us that use it only inside of the class, but it's not going to give us hard rule that we can't use it outside. But if we use this double, we should only use inside of the class. But you saw this function right here that grabbed this value and printed that for us. And if we, instead of this printing, use the simply return keyword right here to simply return this item for us, and for example, we can have this b1 variable to equal to this item right here, and then we can simply have this printing of our B1 of course, and if we clear our output and run again, you can see again we got our result. And this kind of functions and methods that you can see right here, which are going to give us the ability and permission to get the value inside of that private attribute, is going to call our getters. As I told you earlier, we got two concepts right here, which first one is our getters and second one is our setters. And this is our getter, which is going to grab and get the value for us. And it's very good, instead of using this kind of name, we use the simply get and this underscore and the name of our variable, which in this case is going to be the simply balance. And here, instead of show balance, if we use this get balance and run, you can see again we can access to this private variable right here and we can get the result. But if we want to use this double underscore balance, we're not able to do that item. And now let's say we want to modify and change the value of this private variable right here. You know that we can't access that like regular attribute. So for regular ones, we got this, for example, account1.owner, and we equal that with this new value of John, for example. And now if we want to print that, we simply got this print of count1.owner, and if we run, you can see we got this John instead of that. But if we use this double score balance right here, and for example, let's make this 5,000 instead of 3, and if we use this get balance function and getter right here, so we have this get balance right here. If we clear output and run again, you can see again we got this 3,000 because this line cannot set the balance of account 1 to this 5,000. And we're going to do that using our setter. And for that, again, we need to create some simple method here, and this is simply going to be the set underscore balance. And then here again we're going to have the self, but after the self we need to have this value here too. And this is basically our parameter that we want to set into our balance. And then inside of this and inner block, we want to have the self dot double underscore balance, and we equal that with this value that we got from the user. And now this time, instead of this, if we want to use this item, what we can do is account1.setBalance, and we pass the value that we want. For example, 5,000 right here. And now this time, if we run our program, you can see we got this 5,000 as our balance instead of this 3,000. Well, after we got these items, now we're going to talk about property decorator that we got. And that's simply going to give us this option of vSetBalance instead of this form and this syntax, simply by having this account1 and this balance, and we equal that with this 6,000. You know, because we don't have our property decorator yet, if we run this, we still got 30,000 and this is not going to work. And if we want to set our property, what we need to do here above of our getter right here, so we come here and we put this @ sign and then use this word of property. And this is going to make this one the property. But we don't want our property to be get balance, and we want that to be simply this balance. So we got the name of balance right here as our property, and here in the setter we want to have again this @ sign, and then here we need to use the name of our property, which in this case is going to be this balance. So we're going to have this balance and use this dot setter. And make sure after this we match the names of our getters and setters together. So this has the name of balance, this one should have the name of balance too. And now this time, if we run the same code that we got earlier, but instead of using this get balance, we need to change that to this balance. And actually, because we made that this property, we can use the simply dot balance instead of that getter function. And now if we run again, you can see we got the 6,000 with the fact that our item and attribute and member is private. But still, we can use that as our regular public or protected item. And this basically gives us clear syntax, controlled access, and data protection. We still use it like normal variable, but behind the scenes, we can control what happens when someone reads or writes it. But you might have this question of what are the difference of using this much of additional code, and at the end we can able to modify this and use and read this item like normal and regular public variable and attribute. Well, this is the difference. If we got this balance to be public, we cannot control on which number user inputs here. But if we have this type of property and setter, we can have some conditions here. For example, we can have if our value that we want to input is negative number, so it's lower than 0, we want to print balance can't be negative. But in the else part, we can have simply this statement right here. And now this time, if we make this minus 6,000, if we run, you can see we got this balance. Actually, we have misspelled this item, so let me fix this. And now if we clear our output and run again, you can see we got this balance can't be negative. And when we want printing that, it's still going to be this 30,000 that we put at first. But if we have this to be positive number and 6,000, if we run again, this time it's going to set this 6,000 because of this rule that we got. And then when we want printing that, we got the 6,000 instead of this 30,000. In this part, we're going to talk about two of the most powerful concepts in object-oriented programming, which are inheritance and polymorphism. Inheritance lets us reuse code from a parent class, and polymorphism allows us to use different objects very easily with the same code and template. Well, at first, let's talk about inheritance, which when we want to use, it's basically creating new class based on existing class. We're going to have two classes. One is going to be parent class, which is our existing class, and then we're going to create another child class or subclass from that item. And then the child class inherits attributes and methods from its parent. For example here, let's say we got our parent class of vehicle right here. So we're going to have this vehicle, then this is going to have its own constructor. So we got this init function right here. And let's say here we want to have this brand. Then we can have, for example, this color. And let's say we want to have another max speed right here. And of course, we need to assign these values to class attributes. And then we can have another method right here. So let's say we got another function and method right here with the name of info. And inside of this, we're going to grab the self. And here we want to print this f string right here. Then here we're going to grab the color first. So self.color. Then after one space, we want to grab the name of the brand. So we got the self.brand here. And then we say has max speed of. And here we're going to pass the max speed. So we got the self.maxSpeed. And now here we can create this v1 object right here. So it's going to be, of course, our vehicle. And this is going to grab, for example, the brand of Dodge. Then the color can be red, for example. And let's say we want to pass the max speed of 250 right here. And after this, we can have this v1.info function and method. And now if we run this, you can see we got this result of red Dodge has max speed of 250 right here. But now after this, let's create our inheritance and subclasses from this item. So pay attention, this class is going to be our parent, and the logic behind of this is all of the subclasses that we're going to create are going to grab the brand, color, and max speed. And also they're all going to inherit this info method from here, but they can have their own attributes and methods too. And basically our subclasses is things that are going to be that subclass's item and this vehicle too. For example, in our case, we're going to have 3 subclasses of car, motorcycle, and bike, which all of them are vehicles, but all of them has different items based on their own. So first let's create our car subclass. So we got this car right here, and for using inheritance here, after we define the name of our class, we need to have these parentheses. And here we're going to pass the name of our parent class, which in this case is going to be this vehicle. Then inside of this, we're going to have our default init constructor. So we're going to have this def double underscore init right here, then another double underscore, and here we're going to have the self, of course, and then the things that we got right here. So we're going to grab these items and put them right here. And then after we done this, let's say we want to have another additional attribute here too. And for example, in this case for our car, let's say we want to have the seats. And then here we're going to have our columns, of course. And then here below this, because we want our class of car inherits these items from its parent and vehicle, we need to use our super keyword. which this thing basically is going to tell to us that come to the parent class and do the thing that is inside of this. And what we want to do inside of this class is grabbing this init function right here. So we're going to use this dot right here, and this is basically means that instead of this we got vehicle dot. And so instead of this we're going to have this dot, and then we're going to run this double underscore init right here. And inside of this, of course, we're going to pass these items that we grabbed from our user. So we pass those items here, and then because we got another additional thing, we want to define that attribute too. So we're going to have the self.seats, and we equal that with the seats that we got the value from. And just by having this, if you want to create a car object, so we got the C1 and we equal that with this car, then our parentheses, you can see at first we need to pass the brand right here. For example, in this case, let's say we want to have this BMW right here, then we're going to have another option and parameter of color. Let's say we want to have this white, and after that we want to have this max speed. Let's put 300 for example, and then for the seats, let's say 2 right here. And if we come down, you can see this car class does not have any info option and method inside of this, but because we use this inheritance, it can be used from this car too. So here we can have this c1.info, and if we run this, you can see we got this result of white BMW has the max speed of 300, and that's because we grabbed this method from this vehicle. And as same as this, we can have other options and subclasses. For example, let's say we got another class of motorcycle right here, which again we're going to inherit this vehicle and put this vehicle to its parent. Then inside of this we're going to have our init and constructor. So we got this init, and inside of this we have the self, then all of these items that we got here in our vehicle, which are brand, color and max speed, so we put them right here. And let's say at the end we want to have another style of our motorcycle. Then inside of this, again, we're going to use the super keyword right here. And inside of this, we want to use our init constructor. And inside of this, again, we're going to pass these 3 items right here. And at the last, we want to set the attribute of style inside of the motorcycle. So we got the self.style, and we equal that with the style that we get from the user and constructor. And now we can create another object of motorcycle here. For example, let's say we want to have this M1. We equal that with the motorcycle right here. And then inside of this, we're going to pass the brand. For example, let's say this is Harley. Then we need to pass the color. For example, we can have this brown here. Then for the max speed, we can have this 120. And then for the style, we can have this cruiser. And just as same as the thing that we did with the car and our C1 object, we can use this m1.info. And if we run this, you can see we got the car object printing right here, and we got our motorcycle's info coming right here. But we can override our methods too. For example, let's say in the motorcycle, we want to print different syntax and output from our info method. You know, here we got this f string of color, brand and max speed, but here in the motorcycle we can have another function and def keyword right here. If we put the same name of info right here, we're going to override this item right here, which means if we want to run this class's info method, it's not going to run this one, but it's going to run the thing that we're creating right here. For example, again, let's say we want to have another f string right here, but this time instead of putting this kind of output right here, let's say we only want to grab the color and brand. And now this time if we clear our output and run again, actually we forgot to put the self here, so we need to put that. And if we try that again right here, you can see this time we got only this brown Harley and we don't have the max speed printing, because we overwritten this info method right here. And just as same as we done with our motorcycle, we can have another class of bike, which of course inherits from this vehicle and got this brand, color and max speed. And after those items, it got this bell type. And again, we use the super constructor of our vehicle class, then these items, and setting up the attribute of bell type to the bike class. And pay attention, we can have our class variables here too. For example, here in our car, we can have this type and we equal that with this car, for example. And we can have the same thing here in our motorcycle, but instead of car, we got this motorcycle. And we can have the same thing for our bike too. And now after having this, let's get rid of these infos right here. And let's create another bike object. So we have this b1, we equal that with our bike object, of course. And inside of this, we want to pass the brand. For example, here we got this BMC. Then we're going to have the color. We put red here. Then the speed, let's say 30 here. And the bell type, let's say this has the loud bell right here. And then here, after these items, we're going to talk about polymorphism. And basically, polymorphism allows us to use these kind of classes that we created right here and these objects from those classes in very good and simple way. For example, let's say we want to do this info thing outside of the class and by ourselves. So we're going to have this print of f-string again. And inside of this, we want to grab the c1.color. Then we want to have the c1.brand. And then has the max speed of. And here we're going to have the c1.max speed. And we should do this with all of our objects. So here we should change this to M1. All of these are going to change to M1 to use that object. And then the B for our bike object right here. And now if we clear our output and run, you can see we got this result printing into our output. But this is not good way, because if we have loads of objects, we cannot do this thing for all of them manually. And here is where our polymorphism comes to place. We're going to create a list of our objects. And because all of our bikes, motorcycles, and cars are vehicles, we're going to put the name of our list to this vehicles right here. And we equal that with this brackets. And here we want to have the C1, M1, and B1. And then below this, here we can use our simple for loop. We got this for item in vehicles. We want to have this print of f-string, and here we want to have this item.color. And let's say in the next part we want to grab the item brand, and we don't want the max speed right here. If we run this item, you can see we got the white BMW, brown Harley, and the red BMC right here printing with little code and very efficient. And if we have this different info in all of these items, for example, let's say here in the car, we got another info. Let's copy this right here and let's add this car right here. So we got, for example, in our case, it was white BMW. We got this white BMW car has max speed of some number. And for the motorcycle, we got this brown Harley is, and here we can pass the self.style, for example, and we can have another info for our bike. For example, here we got again this info, we got the self here, and here we got another print of this f-string, and again here we're going to grab the name and the color and the brand right here, and then we got has, here we pass the self.bell type, and here we put this bell. And because all of these has their own info method inside of their item and class, and all of them are different from each other, here we can use another cool thing instead of this printing, and that's basically this item.info. And only by having these little codes, if we run this, you can see we run all of our items and objects info method very efficient. We got this white BMW car has max speed of 300 because we got this car word only in the car classes info method. Then we got this brown Harley is cruiser, and that's basically our f-string and printing in our motorcycle. And then we got this red BMC has loud bell, which is our info method in our bike. And basically polymorphism is the same method name, different behaviors depending on object type, which in our case we got different objects and different classes, but all of them got the same method name, and we can use this to run all of their different info methods. And now you know how inheritance works, how we can create child classes, how we can grab items, attributes, and methods from the parent class using super keyword, and how to use polymorphism to treat different objects uniformly. Don't forget to like and subscribe to the channel, and you can check the channel for other cool Python and web development videos that can help you. See you in the next one.